You know that you've been right. Listen to the stores, looking through the windows of a million lives. Listen to the stories, looking at the TV, and you know you can't quite believe the things that you see. So find solace in the sunshine, take solace from the rain, 'cause there might just be a little bit of this world that you can change. And it's feeling good that matters, being true that matters, feeling good that matters. It's feeling good that matters, being true that matters, people that matter. Listen to the stories, everyone has a tale to tell, and you hope that in the end that things will work, things will. And some will make your heart ache, and some will make you smile, and some you don't believe a word, but you hope it works out well. Listen to the stories, watching the world go by, and to think it could be different if we would only try. So find solace in the sunshine, take solace from the rain, 'cause there might just be a little bit of this world that you can change. It's feeling good that matters, being true that matters, people that matter. Good that matters, being true that matters, feeling good that matters. It's feeling good that matters, being true that matters, people that matter. It's feeling good that matters, being true that matters, feeling good that matters. It's feeling good that matters, being true that matters, people that matter. Feeling good that matters, people that matter, being true that matters. Feeling good that matters, being true that matters, people. Listen to the stories.
Test. Okay. All right. So, good morning and welcome everyone to the Research Innovation Ecosystem Conference of Siemens and Friedrich Alexander University, Erlangen-Nuremberg. We are broadcasting live here today from the Open Innovations Lab, Joseph, located in Nuremberg. My name is Isha Salania, and I will be your host for today. I am a business and data analyst in IT data analytics team, and have been with Siemens for about 2 years. Today marks the 6th conference honoring the strong partnership between Siemens and the FAU. It is even more special because we have gathered leading experts from our research and innovation ecosystem, Erlangen and Nuremberg, who will take all of you on a journey across the factory of the future ecosystem. Now, before we dive into the impressive lineup and agenda for today, here are some technical remarks to consider for all of you. This live stream is also being recorded, and you can revisit it at a later instant. Whenever the presentation and keynote is ending, please feel free to drop any questions into the chat below the live stream for the live audience. As for the audience that's present here, please raise your question, and I will repeat it for our online audience as well. When you're leaving your seats over here, please wear a mask in order to go anywhere you want to. Also note that we may not be able to answer all of your questions as time is limited. Now let's have a quick look into today's agenda. We have a lot in store for you at this conference, and as mentioned, it's all going to be about the factory of the future. We are especially honored to have the Siemens CEO, Dr. Roland Busch, and the FAU's president, Professor Joachim Hornegger, with us here today, who will be joining us shortly on the stage. Following 3 exciting keynotes on smart manufacturing, analytics, and services, Professor Joachim Hornegger and Dr. Roland Busch will lead us into a panel discussion along with the 3 keynote speakers. Moving on to the second part of the conference, we will lay our focus to the next generation of corporation, and lastly, we will finish with the startup pitches of the day. That's all from my side for now. I would now like to welcome Dr. Roland Busch and Professor Joachim Hornegger on stage to share some opening words of the event. Stage is all yours.
Thank you so much, Isha. A warm welcome, dear Roland. It's a great pleasure to welcome you here again for such a wonderful event where we show how strong the link between FAU and Siemens is and what different dimensions of collaborations we have in terms of student, professor, and Siemens interaction, or also in terms of lecturing, addressing questions or demanding questions of our times. So looking back to the link between our 2 institutions, I think many of the success we had over the past time is also due to the fact that we interact on a daily level. I mean, FAU nowadays is the most innovative university in Germany, number 2 in Europe, number 14 worldwide. Siemens is a leading company in the global market, also with the attitude to be the innovation leader in particular fields. So that is some kind of perfect match. And in addition to that, I'm a former Siemens employee, and so my heart still beats also for the Siemens activities. And as an engineer, all the topics we address, of course, are very close to those things that I have done and we do currently at our university. For us at FAU, this is a clear win-win situation. For us at FAU, this has a huge advantage for our students. Also, if you look at the degree of internationalization we have, and if you talk to international students, particularly in engineering, the partnership with Siemens is an important factor for students to decide to join FAU. And also, if you look at the hiring strategy of Siemens, many of our graduates join Siemens, work with Siemens, and are very, very successful. So I'm looking forward to the new format addressing the research and innovation ecosystem. Here in the metropolitan region of Nuremberg, we have a lot to offer, and I'm looking forward to the keynote talks, and I'm looking forward to an inspiring discussion that will be followed. Thank you very much. Enjoy the day, enjoy in particular the breaks and the fruitful discussions, and hopefully once you leave Joseph's today, you might have the spirit that we all want to give to you, the FAU spirit, the Siemens spirit of innovation. That's what we stand for, and that's what we work for. Thank you very much.
Yeah, good morning from my side as well, to the people in the room and to the audience who are connected to us. It's good to see people in 3D live again, I have to say. And I just learned that this is maybe the first live meeting here, which happens in this Josephinum place ever since it was founded founded a year ago. So therefore, it's great to see you here and hope you're all safe and healthy. Well, I mean, I cannot underline more what Joachim just said, is that we really have to strengthen the collaboration with universities and companies, and Siemens in particular, because we see that, number one, it's the war for talent, which is on, and recently somebody said that the battle is already won by the talents. So we have to reach out, and we have to make sure that we are really get in touch with young people as early as possible. But it's also about ecosystems that we see more and more in times of fast change of technologies, digital technologies, not only, but also other technologies and new business models, which is an explosive mix, which really makes changes so fast in our industries. Innovation, the own innovation, which we do in our company, is not good enough. We spend 4.6, soon 5 billion euros, which is still not good enough to really take all the challenges which we see and make all the developments. So we have to reach out. We have to reach out to universities, institutes, but also to startups and partners. So we have to focus on what we are really good at and let it go for others who are really working maybe in other home turfs and combine it in ecosystems. And then I thought about, should I talk about future of automation technologies? Maybe, I mean, who am I to talk to you about that? So I give you a different perspective. Why is future of automation so important? If you take, this is a study from McKinsey, if you take the last 50 years, our economy was growing by 3+%. Believe it or not, 50% of that growth, so 1.5%, came from just adding more labor to the market. The other half was productivity to technologies. Now, next 50 years, these 1.5% by more labor shrinks down to a basic 0.3%. So there are not more labor coming to the market. Our society is aging. If we want to keep the momentum of having a growth of 3%, and I'm a strong believer in a growth economy and in a no or low growth, I do believe we need growth. We have to compensate that with technology. Number two, Corona told us how the resiliency of our supply chain looks like. We see, due to the shortage of labor, we see also an increase in the labor cost. So technology has a completely new dimension. I strongly believe, if we look in maybe 10 or 20 years on our map, the allocation of manufacturing looks completely different to what it looks as of today. Next thing is the supply chain. We see that the supply chain is getting more and more important. We want to, not only for resiliency reasons, but also for CO2 footprint reasons. We have to understand that better. If you take that all together, the future of automation doesn't happen only within a plant, but it's really the supply chain from the very end to the very beginning to the end. So that means, for me, this is one of the big topics which we have to address in order to really keep our system running and to allow to do with more technology using less resources. And that's, I do believe, is the challenge which we have, but it's a new opportunity too. It needs all technologies. We talked about power electronics, and it's reaching up the technology stack to the very high end of AI and user interface at the end of the day. So therefore, I do believe this is a topic which is of essence for the economy, the global economy. It's of essence for Germany, and it's of essence for Siemens too. Therefore, I'm looking very much forward to your presentations. Have a nice day.
Thank you so much for the opening words, Professor Joachim Hornegger and Dr. Roland Busch. I want to start by saying that digital transformation and platform economy are one of the most impactful megatrends of the digitalized world that we live in today. And with this, I would now welcome Professor Jörg Franke, who is the head of the Institute of Factory Automations and Production Systems at the FAU. Together with his 120 employees, he has numerous research projects along with Siemens. He will be joining us on the stage today by providing us insights on the smart manufacturing platforms both from a technical and business perspective. The stage is all yours.
So, thank you very much. Well, dear honored president of the Friedrich Alexander University of Erlangen-Nuremberg, dear respected CEO of the Siemens AG, it's a real great challenge to speak after that outstanding persons like you both, and to the specialists and representatives of automation technology of Siemens, the world innovation leader in automation technology. So what could I tell you new about smart manufacturing? I hope, and so the objective of my presentation is, of course, to tell you something about ongoing projects which are very often together with the company Siemens. Maybe I can inspire you, as already mentioned. And someone, please apologize, I do some provocative messages for their unusual positions I sometimes present. Well, I have to talk about smart manufacturing. I was asked to talk about digital platforms regarding smart manufacturing. But I think I have to introduce briefly myself and my institute. As I've already heard, we do employ around about 120 researchers in 8 different research sectors. That's a quite big chair, probably one of the biggest here at the University of Erlangen-Nuremberg, which is not a Fraunhofer Institute. We do concentrate on one area only, and that's the production of mechatronic products. But that field, of course, as you can see on that slide, is quite extensive. Yes, we start with the electronics production. Here we start we do have 3 SMD lines. Okay, the plant in Amberg has, I don't know, 20 or 30 lines. We do have 3 based on ASM, Fuji, Yamaha, and other assembly machines. We do show up every interconnection technology. And from that sound basis of electronics production technology, we extend our interest, our knowledge into, on the one hand side, of course, power electronics. So that's very exciting to develop new interconnection technologies like silver sintering, TLPS, transient liquid phase soldering, and so on. So I think we have the right inspiration to support automation companies like Siemens, but as well, of course, companies from mobility, especially electromobility, to show up the right interconnection technologies. On the other side, you can see here, this is a technology which we started, I don't know, in the beginning of the 90s, last century, together with Siemens, and that's printing electronics technology. And now you see exactly that technology in every smartphone in the world. So several hundred, even almost 2 billion of antennas are produced in that way. We have developed that in the beginning together with Siemens. And now, large companies, production companies in Siemens are utilizing that technology. And we can not only print on a 2D planary surface, as you can see here, we even print on 3D structures in our laboratory, in very fine structures, even that fine that you can hardly see the structure. Well, I could talk a lot about electronics production, but let's switch to electric motors. I always told in my lessons that the biggest plant for large electric motors is in the Vogelweierstraße in Nuremberg. So they produce almost or several thousand electric motors larger than 100 kilowatts. Wow, the students were always impressed. But now, when VW now starts with producing traction drives for their ID 3, 4, and so on, they are producing 100,000s, and very soon millions of large electric motors. And so the question will be, can an automation company with that small volumes keep pace with the innovation coming from automotive industry? And so the technology was well known before at Siemens, these so-called hairpins. Now automotive industry is bringing that into application, into serial production. And of course, we do have to interconnect the different copper bars using laser. We built up that process, developed that for BMW, and now this laser welding technology goes into serial production. We we take off much more power out of the weight, out of the size of the electric motor. The efficiency gets better and the reliability. A lot of advantages which can only be utilized by serial production. But of course, we can develop the whole assembly line for electric motors, magnet assembly, winding technologies, joining technologies, and so on and so on. This is, of course, a fast-growing research area in my institute. Well, what is between the actuators, the control systems, and the sensors? These are the wiring systems. We do have a very strong harness or wiring system branch here in northern Bavaria with companies like Drechselmeier and Kroschuh and Leoni AG and so on. And we do develop not only the automation technologies to assemble the wire harnesses, but also to substitute them. When you in detail analyze Tesla Model 3, then you will see that they have only 1/10 of the demand of wiring systems compared to a standard German car. So we do have on the one hand side automize the handling of the harnesses, but also to substitute the technology. And here we use plasma technology for accelerating copper particles and accelerate them on arbitrary substrates. That's a project together with Siemens in which we do not build up conductive lines on mechanical structures, but we metallize semiconductor power electronic components with copper surfaces using this plasma metallization technology. In wiring systems, of course, we take a look on electric cabinets, for example, and the automated assembly as well. Well, why do we look upon home automation? It's an automation technology as well. We do use automation systems, communication systems, energy efficiency methods, and of course we use robots. The world market for robot is around about 500,000 pieces per year. As much controls could be sold. Unfortunately not from Siemens. But when consumers step into that market, then the demand will explode, as we have seen in automotive. And then again, the question is, where does the innovation come from? From the large-scale consumer market, as we see in the handies or the smartphones, the cars, and maybe even from service robots in home automation. But of course, we look upon the automated build-up of houses and energy efficiency in private houses as well. Then you may recognize that we have structured the chair in line with Siemens. But unfortunately, we are not fast enough to follow the restructuring of Siemens, so that we always have some departments or research sectors which still stay with us. And here we do have, of course, in the core of our research is, of course, the factory automation from the sensor to the cloud. We do develop new technologies. And here, indeed, the question is, we do have the technology to control all the machines, the automation systems from a central computer. Will that happen? No, it will not happen as long as the incumbent vendors do want to sell boxes, of course. So the question is always, when will be a new entrant step into the market and say, I have a completely new idea? And normally, this completely radical innovation or change will not come from an established vendor. Robotics, very exciting. There are so many new ideas in robotics. Here we do show up a completely new kinematic solution, so-called Tensegrity. Again, another project with Siemens, in which we want to build up the kinematic structure of a robot by ropes, bars, and winding drives. Like the human or the natural kinematic of animals and human beings is built up. And we will very soon show up an artificial hand which is defined by this Tensegrity technology. More than that, of course, we develop autonomous robots, moving robots, flying robots. Wherever you see here, we think that the market for robots will explode in the next years. What is engineering system? Again, another department or another business sector of Siemens PL. Here we do use, of course, the complete engineering chain of Siemens, starting with NX, MCD, there's a process simulation, plant simulation. Unfortunately, there's no system for the virtual commissioning up to now, which is missing in that chain. And we do educate our students with the Siemens tools in every semester. And here, of course, we try to simulate multi-physics applications in automation. For example, we won now an outstanding project. It's called DC Hypersim, in which we simulate the energy flow in DC-based factory cells. And we hope that Siemens, by the way, will soon step into the market and offer DC-based components, which we need in such a DC-based automation concept. Last but not least, again, Siemens was faster and sold out health and years. We still have this department, medical technology. What do you see here? We print muscles. We print artificial muscles, for example, based on dielectric elastomeric actuators. These are flexible capacitors made of silicon and coated with electrodes up and down. And when you put a high voltage onto the silicon, then we can contract the silicon. And when we staple these actuators, then we can copy the functionality of a natural muscle, and that's why we call it artificial muscle, with a very high efficiency, 90% and above, with a high flexibility. So robots in the future will not be stiff and hard and dangerous, but very soft. So we call them soft robots, and for that we do need these soft actuators. And first applications, for example, we do develop with a small company in Erlangen, Human Optics, and we do try to build or to copy the functionality of the iris in the eye. There are illnesses in which the iris doesn't work properly, and so we can exchange the natural iris by an artificial one, based on these dielectric elastomeric actuators. All right, this is only a very short glance at current research projects at my institute. And so we have 90% third-party funding. We always have to strive for, well, new projects, 50 in numbers per year. So every month we have to win 4 new projects. So, but let's come to the topic. We talk about platforms, a fascinating topic. For the biggest, the most successful companies are platform companies, as you can see here in dark green. So, of course, Apple. Apple controls the complete ecosystem. And not only the devices, the mobile phones, the computers, the laptops, the smart watches, whatever, all devices can only be bought by Apple. Apple controls the operating system. Apple controls the apps which are running on that operating system. Apple even controls the content. So if you have reached such an ecosystem, then you're fine. This is a company with probably the highest turnover profit ratio. Does anybody know how much turnover Apple does per year with a market capitalization of $2 billion US? So how much sales stand behind that? There's a lot of hardware behind, so it has to be something. Are there estimations? Exactly, 250. 250, so that's about the size of VW. And how much market capitalization does VW has? Right, well, there are more than 100, so in the range, so 120 about VW, but Siemens will catch up, I'm sure. But the good thing is, VW has only half of the turnover, so 250 turnover, 120 market capitalization, and Siemens, the other way around, has double the turnover, So this were strategic moves which increased the market capitalization of Siemens in the last year. So companies which have a lot of commonalities, there are platform companies, they are software-based, internet-based, and they are very young. All these companies are younger than 20 years. Of course, for the internet is only 30 years old. So the companies cannot be older. And they do come, unfortunately, from the US. Some Chinese companies come up. Of course, Saudi Aramco somehow came into that list. They do have that much oil still, but they will drop every year, you can be sure, by the shrinking of the importance of fossil energy in the next years. They all come from the US. The question is, why are these companies that innovative? And what different ecosystem or culture do they have to build up such successful companies? And if you see the rights analysis is done by a colleague, Mr. Schmidt, he compares the different continents, and you see that Europe almost have none importance in the field of platforms. So we are in the same size compared to Africa. So I think we have to catch up and think about what can we do. The problem is that these are all business to consumer platforms. They all sell their services, their devices to their content to end customers. And especially Germany, they are very successful in B2B business. We will talk about that later. And so platforms accompany us through our whole life. We communicate with our friends over Facebook or other social networks. We are not concerned to open our most intimate information. We do shopping over platforms with Amazon or eBay or Zalando, or how they call, directly at the fingertip from home. We don't have to drive to the middle of the city. We do, as you can see here, since Corona, we stay at home and hold our meetings from our sofa. Very efficient, very economic friendly. We follow our hobbies like cooking, for example, with Lieferando, even sports. We do not have to move to the gym. We do sports in a community over the internet on a platform. Even Peloton is already several 10,000 billion dollars worth. So half of Siemens, meanwhile. TripAdvisor, can you imagine to go in your holiday without checking the restaurants in TripAdvisor? No, we always use platforms. The question is, why don't we use platforms that much in a business-to-business environment? And that follows up with the development of the internet, which started in 1990. We use it as a worldwide exchange for information, for data exchange. File transfer protocol is still in use. Streaming services came up, and of course email. I still have my email address, jörg.franke@fabs.de from 1991, with some interruptions, if I'm honest. And then the internet became bidirectional. Social networks, for example, came up. Marketplaces like Amazon and web conference services. This I call Internet 2.0. Meanwhile, we put numbers in our development, and now we are at the stage of Internet 3.0, the Internet of Things. Not only human beings communicate with each other or exchange information, but machines directly. So I can look upon the status of my lawn mower, for example, or the vacuum cleaner. I can have a look into my refrigerator with a web camera, for example. So that can be done directly with internet, with things, and of course things can talk to each other directly. And now we hope that the time of the German technology vendors come, for we are stepping more and more here into business-to-business applications. Again, you see Tesla which have connected, of course, all their cars, millions meanwhile, to the internet. They have over-the-air software services, not only bug fixings, but always new functionalities. And here we hope that in this machine-to-machine-based communication, in the possibility to centralize functionality, knowledge in cloud systems, that we can catch up and offer new services to our customers. We'll have a look in platforms. That's how we structure platforms. Platforms are, in business to business, are quite complicated. I showed up the example of Apple, in which one company controls the complete ecosystem. Here, we do have, of course, we have one IIoT platform operator. Could be Siemens, for example. But there are other system integrators or machine tool builders which make their machines or bring in the connectivity to the machines. The machines are delivered to a manufacturing company, and the manufacturing company provides information, data, to the platform operator. So the manufacturing companies, of course, don't like providing information, secret information to somebody anonymous. Then we do have app developers. We have that in an Apple ecosystem as well. And we do even have maybe database service providers who do as a service the analytics of the data. I will hurry up. So it's very complicated. I cannot imagine that, for example, Siemens overtake as Apple the whole system. And so there are challenges for IoT platform operators and for IoT platform users as well. So do we protect our data or do we share our data? Do we see synergies of scale, synergies of scope by sharing data? Is there Siemens? Do they develop the PLCs evolutionary further and further? Or do they follow a radical revolution and offer control from the cloud, for example? I think that will not happen, while for Siemens will not jeopardize their own business. Will the machine tool builder think in niches, their special machine for special purpose, for special market? Or is there anybody thinking real big, revolutionizing the complete market? I doubt. Or do we strive for technical perfection before we go to the market, or do we strive for rapid growth? These are contradictions which do not help in entering a platform business. Okay, and then now the hope is great. There's a fourth step in this development of the internet. Now the Internet 4.0 comes. We call it the Internet of Values. Not only the Internet of Value, for we can transfer monetary values instantly without intermediary, without bank, for example, via the internet. That will come. That's the Internet of Value. And the Internet of Values means that we do not concentrate the data in one central data storage cloud on the AWS, for example, or the Azure from Microsoft, or the cloud from Google. We leave the data decentralized there where they were generated. And the security is made by blockchain. And the first application will be done again with Siemens. The association is Estanium. We will set that up in the next weeks, I hope. Very exciting. We have not one trusted center. And then we have further projects more, but I have to close. Really? Okay. I start. But okay, thank you very much. We do develop blockchain technologies in electronics production based on Catena-X in a knowledge center. We do engineering. You will see that this afternoon. But again, will Siemens offer their engineering systems on a web-based service, or do you want to sell licenses again? I think licenses is a better case. Okay, and then here, operating system for mobile applications. Here it would be a nice application for Siemens as well. Okay, and do not talk about energy platforms. Would be a nice talk as well. And close my presentation. time goes fast. Okay, I vanished.
Yeah.
I'm very sorry.
Please stay with us. So we will.
yeah.
Please stay with us on the stage.
Okay.
So we'll have a short Q&A session.
Okay.
So we are open to taking 1 or 2 minutes. So any questions in the audience, we would be happy to answer them, or from our online. Yes.
The problem of the Internet of Things is about scaling, and I do believe that B2C solutions scale easier because maybe our buying behavior differs, but the process of getting something from a store and the logistics behind is all the same. This is difficult in IoT systems because the manufacturing environment is different. Isn't that the biggest problem? Finding solutions which are easy to install, plug and play, and scale.
It might. You might. How many PLCs do you sell annually?
Oh, well. But they are the point. This is the point. They are a small box doing always the same. IoT means really you integrate into a system and you do something much more complex, optimizing. And this is the point where I'm.
But the functionality of the PLCs could be overtaken from a central place as well.
Sure.
Doesn't matter how complicated and how different the different PLCs are.
Sure.
So there is a lot of synergies of scale effects, but we do not utilize it, I think.
Thank you for the question and the answer, but that's all the time that we have for this presentation. So, the smart factory is not just about automation, but also about networking complex systems, which requires a high degree of creativity and excellent understanding of technology. The Fraunhofer Institute of Integrated Circuits develops cutting-edge technology for the factory of the future. And today we hear from Professor Alexander Martin, who is one of the directors of Fraunhofer IIS and the professor of mathematics at the FAU. He will be presenting us on the topic of data analytics and optimization in the production and logistics. Please, the stage is yours.
Thank you. Yeah, thank you very much. And as I was introduced, I'm both, so I'm FAU and Fraunhofer, and all the topics that I will show you are also in the interplay between the two and many other companies. I would like to take my focus on the methods that are behind data analytics and optimization, and we actually had already this discussion at the coffee table, and as I got to know, many of us already lived in the early days of artificial intelligence and had their contributions here, and actually we all know that's not new. All the topics that we are currently using, like machine learning, neural networks, deep learning, and so on, they all have been invented in much earlier days, and most of the things that we can do now is all weak AI. So we try to simulate the behavior of human beings, but we are not yet able to have creativity and set up new problems by ourselves. So AI is not possible to do that. And of course, since I'm an optimizer, I was introduced this way, I will also show you that optimization plays a major role everywhere on this picture. As our president is saying, the only thing that works is pattern recognition in AI, and I guess you know these examples, and some of them might be challenging, some others might not be challenging. But AI is actually really successful in this, and our president can tell you a lot of stories about that. But pattern recognition, or classification, if you want, is not the only method that goes around with AI. I mean, we shouldn't forget forecasts, mathematical statistics. We also shouldn't forget simulation, and we shouldn't forget optimization. And what I would like to do is to show you now a couple of examples where you need the interplay between two different types of these methods. And before doing that, let me hint one more word about the methods and the development of their methods. And I have here the progress of an optimization tool within the last 20 years. So Bob Bixby is an inventor of two very successful companies. He's, by the way, also visiting professor at the FAU. And you see here the progress of the software package over the last 17 versions, last 20 years. And the speed up factor of the algorithm was around 1.25 million. If you look simultaneously in the speed up factor of hardware at the same time, it's around 2,000 only. So whenever you have €1 and you want to spend, you will spend it in hardware, or do you want to spend it in developing new algorithms? And so you get much more out of it if you spend it in algorithms. Of course, at the end, you can basically multiply both factors together. That means that problems that need to around 50 years of solution time 20 years ago now can be solved in microseconds. So this also means that these tools can now be used in a daily life and in every single decision, online decisions as well. And I will show you a couple of examples now. The first one comes from the spare parts demand. So Bosch, Siemens, Hausgeräte, you might know. So they promise that you can always get your machines repaired. So if the 80-year-old grandma has his 50-year-old washing machine, Bosch Siemens guarantees that it get repaired whenever there is something. So how do they do that? Of course, there's at some point the end of production, and from that point on, you need everything in your storage. And of course, you need first a good forecast for all these spare parts, but also you need an optimization to when do you buy your spare parts. And the problem is they have over 500,000 of these spare parts, but the data for each single spare part, basically you can't use for forecasting. You have some data here, some data there, but it's just too sparse to use it. So you need a clustering, yeah? And first, this you do with classical machine learning, and then you have representatives from each, and this then you can use for a good forecast. And then the next step is then it comes the optimization, and here you see in green basically the line that is the forecast, and the blue line is when do you buy how many spare parts, yeah? And then you see how this nicely fits with the demands. And here you see a connection between clustering on the one side, forecast, and into optimization simultaneously, and this can be all done within seconds, yeah, with the methods of today. The next example is about efficient timetabling. You all know that energy costs do not only depend on the consumption, but also on the peak that you need. Yeah? And here you see a project that we run together with Deutsche Bahn. So the question is, can you shift the departure and arrival times of the train in such a way that the peak is at least as possible? And in red, you see that every tenth of a second you get the consumption, the energy consumption. This is leveraged in 15 minutes level at the blue line. And the question is, how can you reduce this blue line in order to save money? And indeed, this is possible by slightly shifting only within 1 or 2 minutes, yeah, to do that, and you save up to 10–15%. Yeah, this would result for the Deutsche Bahn in around 5 million. Of course, the Deutsche Bahn has a problem that the locomotives are not yet automotive locomotives. But the Nuremberg subway system is automotive, and we did it for the Nuremberg subway system together with Siemens, because the software is coming from Siemens. And here you have, again, the same savings. Of course, it's not the same scale in euros because it's smaller. And we are now getting started in how can we do that together on the market. And of course, it's not only for scheduling problems. I mean, you have it in production, you have it everywhere. Yeah? So even my small friend, a craftsman in the Schmalau here, has the problem when to switch on his machines and when to switch off. Yeah? So you have basically this problem everywhere. And just with a single change in the software, you can really save lots of money here. Another thing is optimal control of supply networks, and especially in the energy market, if you look, there's a lot of things going on at the moment. We all have the discussion about hydrogen, how to switch from natural gas to hydrogen, how to set up these networks, how to control these networks. And this is really challenging from the modeling point of view and also from the method point of view, because you have to model the physics, and it's not easy. So typically there are partial differential equations involved. On the other hand, you have these switching elements where you can switch off valves or compressors and so on. And to model and have solutions for this is really challenging. And we have set up a corporate research center at the moment where we really address these questions, and we can really solve up to 10% by doing this all automatically. Of course, still challenging will be the high dynamics that come into the play from the market. And of course, when you now switch to hydrogen, because hydrogen has other physical properties that might be challenging in the future. Another interesting thing that I want to point out to you, and this is, I think, also maybe a point for discussion, is at the end. So this was a project together with Linde, where it's about assigning service technician to their customers. You know, all these cylinders which have different gas in it, and they have to take care of that automatically. And the question is, who does this serves which customer? And you see here two solutions on the right. One more in say grouped together in fields, connected fields, and here on the right below you see fleckless Teppich, whatever the English word for that is. And the problem is, so which solution is better? Yeah, the fleckless Teppich is better, yeah, by 7% in cost. Which solution has been chosen? The one on top, because everybody thinks the one on top is optimal. It looks optimal, right? And how can you convince someone that the fleckless Teppich is optimal? Nobody would believe you that the fleckless Teppich is optimal. Yeah? And so this is also something we have to address. Yeah? I mean, we want to solve more and more complex problems, but we still want to have simple answers. This will no longer be possible. Yeah? So we have to have a discussion on how to address also the human beings at the end, because they have to take the decisions, how that they are convinced that they take these complicated solutions. And I try to summarize this here a little bit. So there are a lot of challenges showing up. I mean, the data availability we know, and data quality and quantity. And why has been AI now getting a new push? Yeah, it was because they won in games, yeah, in chess, in Go, and so on. But this was simple pattern recognition, and the algorithms could choose data. So they played against themselves, so they had data available as much as they want. And they could check whether it's real data, because they just have to check the rules. In reality, it's different. Yeah? 7 billion human beings is not a big number. And we always think we can deduce from these small numbers good interpretations. And of course, the same thing that was addressed in the beginning, in the opening, available resources. This is all the things we need to discuss. We need people who understand the methods and can improve the methods, not only apply the methods, because many things go wrong if you apply them in a wrong way. And as I said, in the last thing is also this acceptance. How can we get better acceptance for these methods that we use in AI and data analytics? Yeah, and that's it. Get in touch. We are together. That's great. And I'm open for discussion. And maybe I also saved some time already from Ellen.
All right, so we are now open to any questions from the live audience and also online. So feel free to ask your questions, yes.
Dear colleague Martin, how dependent are we from tools and hardware, also software tools and hardware systems from abroad, from especially the US in AI?
I mean, many tools are from there, but we also have a lot of tools, and we are still developing with these guys the tools together. I mean, of course, the one that I mentioned is a US tool, yeah, and they are typically ahead, but they have also easier ways to set up companies. I mean, I have the discussion with Bob Bixby always. It's much simpler in the US to get founded a company. Yeah? So many people share the risk. We don't have this. So all the risk goes to the company at the beginning, and they share risk among themselves. He has Shell as a partner at the very beginning who shared basically the risk. Yeah, and so he could easily grow.
All right, thank you. Yes.
Well, now I come back to your picture of image recognition at the beginning. Yeah. When you want to train your AI algorithms, I assume you have to show 500,000 or 1 million of pictures to your algorithm to train them. Luckily, you don't have to show as many pictures to your child when they grow up until they recognize a dog or a cat. Why?
I think it's human beings have their abilities in different fields than AI has. I mean, where human beings have difficulties if you want to see the differences. Yeah, if you have maybe in former days in the Mickey Mouse there have been 2 pictures, see the 8 differences. That's difficult for a human being. For the computer, it's easy. You subtract the 2 pictures and you see the 8 differences. So I think we have to learn where human beings are better and where the computer is better, and we mix the things at the moment. And I think we need both to be successful.
All right, thank you. We have one question here. So how relevant is this for small, medium enterprises now and in 3 years?
Many of these examples, I mean, 2 examples I had from bigger companies, but we had a lot of cooperations with small companies who cannot afford their own data analytics department, and they do that with us together. And for them, it's really in the same way important as for any other company. And I always recommend they get in touch with us. I mean, you said it at the very beginning. We need to develop these things together. We always try to do, I do that, you do that, then we have a long discussion about IP rights. Why not sharing it right from the beginning?
I absolutely agree with the statement. So if there are no more questions, any more questions in the audience? If there are no more questions, we will now move on. Thank you so much for the insights that you've shared. So, all of you must have surely come across the phrase that data is the new gold. With the digital transformation of the industry, more and more data is being generated, which offers an opportunity for new services that will arise. Hence, I will now present to you Dr. Marina Wallisch, who is the Vice President Service for Factory Automations at Siemens, on the topic of the age of data, future factory services, and beyond. Please, the stage is all yours.
So, almost 20 years ago, I was a student myself, just like some of you here today, or of course in the live stream. I had a bit of an odd passion. Nothing that was cool enough to brag about at parties, but something that very much rocked my boat. Predictive analytics and statistics. One day, I presented some of my university results to my university colleagues. Then a little conversation started. I never forgot again. One of my colleagues, he was wearing a hoodie from one of the world's leading universities. It was not FAU. He came over to me and asked, Marina, why did you choose to specialize in predictive analytics and statistics? Firstly, I was so excited because I thought I might find someone who is as much into the topic as I am. So I replied that formulas, algorithms, and numbers are easy to me, and I so much enjoy working with them. So, the colleague said, "Hey, sure, great that you enjoy working with them. But Marina, you do know that they will never get you a job." I was shocked. Firstly, I didn't know what to say. So I smiled shyly, maybe a bit like a nerd. I went to the vending machine. I bought myself a Coke and sat down to think about whether my passion for algorithms was nothing else than a useless fun hobby. Hey, I'm Dr. Marina Wallisch. I'm responsible for the global service business for factory automation at Siemens, specifically at digital industry. I'm quite sure, and you've heard it from Isha already, that all of you had heard the phrase already. But, and I can tell you, it's actually true. Data is the new oil. But in order to fully grasp the meaning of the phrase, I would like to show you today some real-life context. So therefore, the next 15 minutes, I would like to talk about the age of data, future factory services, and beyond. Let's go to an automotive factory in Hungary. Imagine one little insignificant screw went across a drilling machine. Boom, defect. Due to that little insignificant screw, that can cause, of course, it can lead to an increased oil temperature and can cause serious damages on the production line. In our case, the production line stopped. No service engineer would have ever been able to detect this failure due to standard maintenance. So that means, in total, we had a damage of a downtime of more than 1,000 minutes, and more than 800 car bodies were affected. So, this little insignificant screw cost our customer more than €1 million. But here comes the good news. Luckily, this example never happened, because we predicted it. By using data, my beloved data, minority algorithms, and of course, AI. So, how did we do that? The solution is quite simple. We tested it with several customers, in our case, at a factory in Hungary. So, the customer pays per asset that is connected and transmitting the data by themselves somewhere to the cloud. It can be any cloud. It can be Alibaba, it can be Azure, it can be whatever cloud makes you happy. So in the first stage, we collect the data, and it can be the data from one machine, it can be the data from several machines. In the first stage, we differentiate between total, relevant, and irrelevant data. So we analyze it, we upload it, we analyze it. We can actually analyze many different kinds of data, but what we want to understand is the future health of the machinery and what exactly requires service attention. So we use different kinds of data, for example, maintenance data, machinery data, and also maintaining behavior data. The data gets supported and compared by more than 150 algorithms to similar assets. Unsupervised, of course. That's why we call it automation. It's a full automatically process modeling that doesn't even require any technical expertise, whether for onboarding nor for data quality checks. So as we want to see the results by humans, we transfer them in very easy to understandable dashboards, where actually any anomalies can be shown as early warnings in the dashboards. So our maintenance staff will see then if there is a potential need for action already in a very early stage, and they can plan their check and repairs accordingly. So for us, it's about collecting the data, understanding the data, and using the data. The system is cloud agnostic, vendor agnostic, and asset agnostic. And it can be used in pretty every industry. As I've mentioned, we've tested it at an automotive factory in Hungary. In the meanwhile, also with other customers. One of our customers, a tires company in Germany, they choose not to invest in predictive maintenance. So, once there was a failure, it wasn't detected in advance. So the production line started to burn on a Friday evening, and therefore was out of order for more than 12 hours. I don't know, maybe they hired my university colleague with the Ivy League hoodie. You go and figure the cost, the loss the fire cost them. So, I have another example for you. In my previous position, I have another example for you because I personally believe data can make the life of our customers so much better in so many ways. In my previous position, I headed a project that was called Data-Driven Business at Digital Industry. Therefore, I conducted many different customer interviews, also with customers that were already using pay-per-use base for their machines and systems. The customers who were dealing already with the new business models told me that one of their biggest challenges is that their customers didn't consider their invoices to be credible. I understood the challenge. As you might know, one of our Siemens values is that we have built very strong relationship of trust with our customers over the decades. So I was wondering, how could we match the customer challenge with one of our Siemens strengths and therefore act as a neutral party between our customers and their customers? So we started to develop a prototype in a kind of notary service where we as Siemens act as a neutral part between our customers and their customers and therefore reduce the lack of trust these parties were facing too. So, in this case, Siemens is in the position that the customer trusts us whenever we apply with a Siemens-approved seal on the invoices. After, of course, we have used data and algorithms to identify whether the invoice is correct or not, so that the two parties can trust each other and especially the data that are transferred between them. I have another example for you. So let's keep on going a tiny bit. We've talked and heard from Professor Franke today about platforms and B2C challenges that might be difficult to transfer to the industry. This example is from the B2C area. I personally believe that many of the examples from the B2C area can be transferred to the industry. So let's start with an idea and a platform pretty everyone is familiar with, or some platform concepts. It's about Uber, it's about Airbnb, it can be My Hammer, and of course, like in the example here, Free Now. So what can we learn or how can we transfer these concepts to the industry? Imagine, person X is looking for a service A and is therefore looking at a platform for someone who provides service A, ideally in the field of working or living. So, as we all know, when the transaction was successful, the service provider receives an agreed payment for that. We do have this in place. It's called Swift, and it's a platform we actually offer parts of our customers in the Asia. So it's actually quite simple because it allows a number of parties to request and offer services. With just a click, service requester can upload their error reports or a video of a defective product, and they will then receive offers from service providers who hopefully they can fix the problem. So, as we've heard also today, for each transaction, Siemens would receive, in addition to very valuable information about the installed base the various customers have in place. So this is an idea. It's in place, and in the future, it's going to be an unlimited service marketplace for any kind of services. It can be starting from fixing machinery services up to gardening. So it's a bit like, for those who know it, the platform Fiber, but just for maintenance. All right, so I have one more example for you to go to. The factory of the future will depend on seamless devices. Machines will be able more and more to communicate with each other. In addition, machines will be more and more instructing the factory workers how to deal with any difficulties, and they will predict their own downtime by using data and algorithms. So, I of course know many factories are not so digitalized yet. Factories and factory workers work in many cases manually, as you can see here. But again, in a not so perfect digital factory, one of the workers is having a problem with one of his machines. So he urgently and desperately looks for someone who can support. And as it's Murphy's law, the moment you need a coworker, they are all for lunch. So the poor, stressed factory worker is rushing back and forth in the factory, hoping to find someone who can fix his problem, as he failed several times. This is a totally real-life scenario that happens several times a day in different factories. So imagine this employee could simply request help via his smartphone, or his smartwatch. So the others would receive a push notification and can go offer help in return of receiving any bonus points or incentives in addition. This example would help us to improve the efficiency by tracking waste in the factories, by providing fast response when support is needed, and we would get the transparency of the community in a factory, and therefore would know who is the person that always supports and keep this motivation due to extra recognition high. So maybe you can take, for the moment, 2 things out of my talk with you. Firstly, it's really worth to think about your company's strengths and how you can use them to solve any customer challenge. As I've mentioned, one of our values is credibility and trust. So what could be yours? The second one is business models are currently going under a huge transformation, especially in the X as a service segment. There will be many new opportunities in the field of services, especially due to fintech solutions. I personally fully believe there will be many potentials for us and for all the players in the industry. So, to sum it up for the meanwhile, all the mentioned examples are part of our service vision and of course focus topics such like data-driven business. We have many ideas out there and we are trying, of course, to test and implement them in very fast responding loops. So, when you've heard the examples today, I think it's quite clear. It's not just a matter of reading machine data. It's really about making intelligent use out of the data for communication by finding application that supports and helps the entire value chain for getting more cost-effective, more efficient, and more productive. So what we want to do is we want to help our customers to get out most for their business by using, of course, platforms to connect also our customers with each other. And by doing that, we definitely want to help them to act as sustainably as possible in their process. For example, by reducing idle times or also saving actual resources. And I fully believe predictive maintenance can contribute on that. As we all know, predictive maintenance can support the extent of the life of assets. And in addition, there is a huge potential to optimize the energy consumption. So, what did I learn? Firstly, the nerdy algorithms and statistics matter. So please, whenever there is someone with a hoodie from a fancy university or company who tells you something you're passionate about is useless, go to the data-driven, cloud-operating vending machine, drink a Coke, and think about which problem could be solved with your passion and if there is a niche to start with. Thank you very much.
Perfect. We're now open to any questions that the audience may have. All right, then I have a question of my own. So in terms of predictive maintenance, I want to talk about a specific example in factory and more specific vehicle diagnostics. And there what you know is that a mechanic can just listen to the sound of the car and tell you if it's working well or not. Whereas if you do the same with algorithms, it takes the sound, in order to detect the sound and analyze it, it takes really long. And also to train such algorithms also isn't as efficient. So what are your thoughts on that? And how do you think we'll have a complete automated factory in the near future or not?
Well, I don't think we will have a complete, fully automatic factory. I think there's always some human resources and power required. I mean, the example was what you said is something we experience in many cases. As you totally correctly mentioned, using predictive maintenance, especially the algorithms, you need a lot of technical expertise is required, and in many cases it's not so automatically. But with this solution, what I presented, we really have something where I said we have more than 150 trained algorithms. They work fully automatically in many different kinds of assets, not in everyone yet. And this is the next step what we could make. It's also applicable for many different kind of industries. So I agree, when we talk about algorithms of sound, it's definitely something different than when you analyze typical patterns like vibration patterns or temperature profile or energy consumption. So the complexity of analyzing really the sound due to data is definitely, again, a different stage.
Thank you. That answers my question. Yes.
May I ask another question? Your examples showed clearly that it's quite difficult to find groundbreaking new ideas for platforms in ongoing businesses. So your customers are in a strong competition. They improve their businesses by 3 or 5% productivity every year, constantly over the last, I don't know how many tens of years. How, and if you look to improve that productivity increases, I don't know, by 10%, even with what is a big leverage, then you would improve the whole business by 5 promille. So the question is, how can we look for real groundbreaking new ideas where we do have radical changes in business? Or do we always, even with these new and powerful tools, do we always only evolutionary improve businesses?
You're asking, I think, exactly the right person. I think both ways are right. Firstly, we definitely have to be very challenging and maybe a bit respectless in point of challenging our own fields of businesses. Because if we don't do it, others will do it. So yes, we definitely, of course, we think and challenge the current status quo and how we can disrupt the businesses even more to create something really disruptive, groundbreaking new. This is one thing. But you know, if you do that, we do have a CFO who might not be that happy or so willed to invest in something like that. The second thing is, and I mean, as I said, you have to keep really both ways in your view. The second way to start, and this is the example what I said with, you get a push notification from the factory worker who needs support. This is something where we actually started very small. Parts of that are currently under prototyping in Asia. Parts are still visionary, right? So this is something where we start small, as you said, a bit evolutionary, and we try to scale it up to the bigger full size whenever the market and our customers are ready. Because currently we see a very different stage of the digital maturity in our customers, at our customers. So this is something, if you want to make business out, you really have to specify first where is the market, who is willing to pay who is willing to pay money for your ideas, and of course, is there a potential to scale it? And then, you know, if you start very disruptive and the market is not there, it might take a while. But of course, you're right. You have to do both.
Isn't also the brownfield a big challenge? I mean, if we think about B2C business, then it's always a greenfield here, and we have to go in a brownfield.
Of course, definitely.
So just to repeat the question, so is brownfield also one of the challenges?
Absolutely. I mean, whenever you start in greenfield, it's quite easy because you can design the whole architecture by yourself and then you do it exactly the way you think it's right. When you have a brownfield, and in Germany, in most of pretty every cases, it's a brownfield start, or in many cases, we still see some factories like the Gigafactory in Berlin coming, which is then more a greenfield than a brownfield. But again, right, at the end, it's about the same. We need to find ways how we can connect the assets to get the layer points, and then, as I said, create the most for our customers with their data. It is a challenge, especially from a technical perspective.
Perfect. Thank you so much, Dr. Marina Wallisch. So now we will have a 15 minutes short break. So feel free to grab a coffee or a beverage. And once we are back, Professor Hornegger, along with Dr. Roland Busch, will lead us into a panel discussion with the other speakers. So now's your time to network, so make the most of it. Thank you.
Oh, you're free.
Now it will be very exciting who will choose this one. So, welcome back from the break. We will now have a panel discussion with all the speakers and with Roland Busch about the talks, about future directions, about demanding questions. And I kindly request all the speakers and Roland to come up to the stage.
You know, there's a pattern. There's a pattern.
No.
There's only one lady.
Yes.
Oh, yeah. No. So,
Yeah,
So therefore,
relax.
Is there a rocket
I'm
ship?
better sitting on the CEO's left-hand side
Okay.
than right-hand side. That's the more dangerous one, I can tell you.
Thank you so much for your presentations and the discussion we had on a few topics. I want to dig into a few problems and questions that appear quite demanding from my point of view with respect to the future development of our economy, of our innovation processes, in the way we deal with AI, with data, with future automation systems, with respect to expertise in mathematics, how should we interact with each other. So there are a lot of interesting challenges we are facing. Data is the new oil. You have mentioned this. This is a common saying that we are using every day. And within Europe, I observe that we have a few issues to be solved. For instance, if you look into the medical arena, it's hard to get patient data out for the training of AI algorithms. If you look at factories, you have the question, who is the owner of the data and who owns the knowledge that is generated out of the data? And one thing that is very specific for the environment in Germany is data protection. Yeah, who protects us from data protection? My question is, how do you consider data protection, data ownership, and these tasks in terms of our future in AI within Europe, within Germany, within our economy? Who wants to start?
I mean, you are right. I mean, we have really problems how to specify who belongs to data, what is the data worth. I mean, we even don't have yet prices for data. Some data are simply to generate, others are really complicated to generate. We don't differentiate between different types of data. And I think we have to be really more open-minded in this respect, because as long as we save the data more than ourselves, we won't make any progress. And we had this in the pandemic. I had a discussion with a lawyer who said, well, everybody had to dispense with some of our rights, except the data rules have never been changed. Yes? And this was really a problem. Yeah? If you look at Corona apps and so on, we have all the techniques, we have all the tools, but we are not allowed to use them because of that. So we have to change our minds in this respect.
Marina, looking into your specific field where you are working, servicing, you learn a lot out of the experience of your customers, and you use this knowledge to further improve your systems and your service structure. So how do your customers respond to the implication that you improve your systems and might sell the same equipment to competitors, for instance? Is this an issue you are facing, or is this something that is not within your environment?
I would differentiate a bit. I mean, as we've heard from Professor Franke today, it's about platforms and scaling, business modeling, and platforms. So I think we need to differentiate a bit between the OT world and the IT world. And the OT world gets more and more IT components, and whenever more IT components come in there, of course we are in a world where you can use similar systems, similar offerings several times, because otherwise it wouldn't scale, then it's, for us as a company, not really interesting. Do our customers really have a problem with that? That's what your question goes to, right?
Right.
I mean, we are a global company, right? We have customers in Asia, we have customers in the US, we have customers in Germany. And what we definitely see, there are some differences between the cultures and how sensitive customers are by using similar systems products several times. In general, I mean, German is the more difficult market when we talk about data-driven business. That's a fact due to some data regulations and restrictions. But again, I mean, we are a global company, right? We can do things in the US and in China. And when the market in Germany is ready, we can bring it over here. And yes, then of course it's a reuse and a scaling. But that's what the IT world is about.
Yeah, I mean, if you let's talk about machine tool manufacturers. Of course, they're sitting on their data because they believe that they go into a service-driven model as well. So manage my machine or have a machine as a service kind of business model, which they start off. And this is based on data at the end of the day, because if they have the reliable data, then they can say, okay, this is the way how machine was used, and this is the reason how my customer is paying or is paying not. So it's the point. It's about IPR rights at the same time. So therefore, I do respect that. Number one. Number two is we don't have to own the data. I think as long as we can train our algorithms on them and we treat them properly, I think it's all fine, and they understand it better and better. But the real problem is, and I'm fully behind having a certain regulation, in particular if it comes to personal data and machine data, you have to respect it, because if you don't have a regular framework, then people tend not to share, and that's a problem. But this brings me to a point. In our private life, we do have also a regulatory framework, no? Because when you create an Amazon account, an Apple account, you get a long list of contracts, but you don't have a lawyer sitting next to you, and so you click it and you go for it because you believe, I mean, what shall I do? Anyhow, I'm going to use it. B2B is a little bit different. Every time you want to do something, there's a lawyer sitting there and tells you, okay, here's a problem. So what I'm saying here is, the moment you, in the business, this is all about ecosystems and about sharing and getting more out of it. And every time you buy something from your online or from Amazon, whatever, you share something and you get something and you share information, whether you want it or not, or whether you know it or not. And this model, if you transfer it into B2B business, it's not known yet. People say, I mean, why do I share my data? But they get much more out of it if they start using it. So if we can get this kind of mindset into our B2B business, in our industrial business, I do believe we make a big step forward.
Yeah. That's something we have to work on.
I think we should speak clearly. For we are in a society in which not the raw material or the capital or the workforce, maybe the workforce is a crucial production factor. It's the knowledge, and the knowledge is based on data. And nobody would never ever give my data away if I would be concerned that the competitor, the supplier, whoever, my customer, could take advantage out of the data. So the data is mine. And I tried to, I had to less time, of course. And it's not adequate. An internet platform provider is collecting data from everywhere and is doing something with it. And we do have the technological alternative, not to bring the data to the algorithms, but the other way around, to bring the algorithm to the data. So I keep the data. The data should never go out of my site, and the algorithm come to the data. And we should be capable to have our learning, our data analytics, our machine learning, training tools. They should be capable to use, to train data which is decentralized. I think that would be a game changer if we could build up a competition to the hyperledger and to the platform provider, if you could say, you keep the data, and we only take advantage if you bring the algorithms to you.
Very, very interesting and important idea. I mean, there are, of course, a lot of practical issues that have to be resolved. For instance, if you need annotated data for the learning algorithms, then you have to send out people. And but it's an interesting idea not to hand out the data, but providing access to the data in an encapsulated way that you do not violate the data privacy. Roland, one question from your level of abstraction. What is the added value?
Whatever that means, huh?
Well, you have the overview of your company. One question that we always ask ourselves, what is the added value for a company of AI technology? Is this something that you can quantify in a certain amount, saying we invest so much in AI technology and this will be a driving force for our future business to a certain extent? Can you give us a feeling about the importance of AI technology at Siemens?
Yeah. So can I quantify it? Not yet, or not precise. We have our software and digital service business is 5.3 billion, and we want to grow it by 10% or more going forward. How much of AI is in there? I mean, it's hard to say. What I do know is that we have an increasing number of AI experts. We have a corporate technology field for AI, which is, if I'm not mistaken, the largest one regarding the amount of units which are contributing, but also the money we are going to spend. It is maybe the fastest growing one. So actually, therefore you see, and this is paying into many, many different cases of digital services. Mm-hmm. Is it in buildings? Is it in infrastructure? Is it in the manufacturing shop floor? Is it in service? Service is a big, big thing. Because the service is exactly the point where we are creating data, where our technology is creating numbers. So therefore, this is the place where I would really start in looking into it. We are going to digitalize our building technology service business, which is the largest business unit which we have, and we want to really digitalize it completely based on data-driven and AI services. Why? Because we don't want to go with a service engineer to a place where the textbook tells you when to go there, but we have to go there when something happens, or even before it happens. That's the idea. So therefore, I do believe that's it's not quantifiable, but it's a huge impact today, and even bigger going forward.
I would like to add an example on what Roland Busch said. I mean, to think about sustainability and the whole discussion about circular economy. This works only with AI. And I mean, there is no way around for that in the future. We need to focus to reduce our decarbonization and carbonized footprint. And by doing that, we definitely need AI. Mm-hmm. Otherwise, it's not working.
Mm-hmm. Being a representative of a research institution like our university, let me ask the following question. You have mentioned that you studied statistics and you are an expert in predictive analytics. You explained to us that it's way better to invest in smart algorithm instead of investing in hardware in terms of innovation speed. You have explained to us a wide range of different applications where AI plays a key role. And I have experienced and learned from one of my colleagues in mathematics who read one of my papers, if you would know something about mathematics, you could be way better in what you are doing. And this tells me that the linkage and the collaboration between the different disciplines and the expertise, the in-depth expertise, is very, very important to become a leading position in AI research, but also in AI applications. And my question to you, Jörg, is what can we do from our point of view within the interaction with industry, the interaction at the university with all the basic researchers providing all these wonderful ideas to accelerate this type of interaction to get the better algorithm, and at the end of the day, the better algorithms than our colleagues in the US or in China?
Well, I'm a little bit concerned, if I'm honest, for the, again, I'm provoking as always. For on the one hand side, the tools, the algorithms, the real capable AI tools are developed in the US and a little bit more in China as well. And the reliable data is generated in East Asia. For the bigger the database is, the more reliable the data are. And where are the big production plants, production sites? They're not any longer in Europe, but they are in Asia. And so they produce much more data, information, experiences, knowledge than we ever could. So we do produce in small volumes, small lot sizes, specialities in machines, whatever. So we do not have the basis for the data. And our production, our process research from 100 years, we still follow the ideas of Mr. Kienzle, doing experiments and learn that, try to model the world and predict the world by reliable models, that could be not that important any longer. For we learn more, as you said, from neural networks, just by observing the processes and not by modeling it in depth.
Yeah. But Alex, what can academia do to adapt to the change of the landscape within industry? I mean, this is happening in enormous speed, and you know about the speed of changes at a university.
Yeah, that's true. But in both cases, I mean, the change, the speed of, I think we have to do the things together. And we always discuss about, so you wait until someone has a master's thesis, then you take him or her. Yeah, why not coming earlier into the play? Or when it comes to the PhD, why don't do things together? We discuss about IP rights. So this is my right, this is your right. Why don't share that even? I mean, at the end, you buy it anyway. Yeah, but so we are more slowly at the university, and then we have the IP rights, and at the end, you buy it. Why don't do it together? Then we are much faster, and you have it already right from the beginning, and at the beginning, I have also part of the share. So we need new concepts on working closer together. You have the expertise in the applications, you have the data, and we might have the cutting-edge technologies and methods. And bringing these together and let work the smart guys and girls together would much more accelerate the research and the application at the end and solutions.
Jörg was quite provocative, showing us the platform technology and the level that different countries have reached. Is it
before
true?
you go on,
Huh?
what shall we do?
Yeah.
What shall we do?
Yeah, I think if we could rely on our strength and take opportunity of the chances we have, and not always evaluate, do we have a danger, a risk to jeopardize our ongoing business, then we would probably see more innovations from incumbent established companies like VW or Siemens or others. So that's, the success is our biggest problem we have. Yeah. So can we really change, having in mind that we are that successful? I'm afraid we can't. Professor Vogt could explain that better. He does innovation at the FAU, but I think it's a real problem. We analyzed 10th of companies, S-curve analysis, and we always see the new S-curve vanished out, wiped out all the old vendors. And do we always have to wait until the next S-curve will drive us out of the market? Or will there be a chance to take advantage of a new technology? I had some slides with me. Unfortunately, I couldn't show you.
No chance.
No chance. I could bring it.
You will get not a further slot for your talk. Yeah.
Such a pity. I thought I had the CEO of Siemens in front of me, and I could give him some.
But how do we identify the next big thing, and how can we be faster than others? So
one example
what is your recommendation?
Electromobility is a big thing, and the biggest problem we have are the batteries, is storing energy. In a car, does it make sense to have a battery with 100 kilowatt hours carrying with me, weights, I don't know, several hundred kilograms? We do have the technology to transfer the energy while the car is driving. Since 10 years, Siemens developed the technology, but never brought it into the market. I don't know why.
So we are trying hard.
No, you stepped out of the idea.
With the e-highway.
Yeah.
Yes, these are the
which is the
Very
by far less
yeah.
costly than digging into the ground.
Yes, again, we focus on the niche market. We do the world market for heavy trucks is 500,000. The world market for passenger cars is 100 million. Why do we only offer a solution for these 500,000 trucks we bring newly in the market, and not for passenger cars?
If you two guys are done, I would like to ask the next question.
One example. It was only one example. I have many others more in which you could.
The answer is very simple. It's a business case. Because you can drive with a car with 100 kilowatt hours, because you don't drive. I mean, in most cases, it's more than enough.
Yeah.
For the truck, it's not. In the buses, it's not.
Take 200 kilowatts.
Yeah. Yeah.
But the business model is much easier to explain, because the business model is suppressing the driver.
Marina, one final question. We have 1 minute left for you. You have mentioned you have a global business, yeah? And my question is, do you think relocating to China might speed up the processes that we have to deal with?
That's a tricky one. You actually, I would need to pass.
No, I want your answer.
Me too.
Okay, I don't feel under pressure now, no worries. I mean, to be honest, China is a huge market, and as Professor Franke said, there are partly many more opportunities than we currently face in Europe, right? I personally believe that, especially in Europe, we need to take really care that we don't get too much lost behind US and China, and your slide with the platform example showed that quite good. So, and as I've mentioned, the example with Swift, which is also a platform example, but also the thing with where the factory worker can request their help on a smartwatch or smartphone, is tested in Asia. So, why do we test it over there? Because, you know, it's much easier to do that. So, of course, yes, this has something to do with speed.
Thank you so much. Thanks for the discussion, and thanks for the passion you have shown. That's important to have this type of innovation spirit we want to have in the region. Thanks a lot.
So thank you for the great discussion here. I hope everyone enjoyed that. Now we move on to our next topic. So cybersecurity is of great importance in the factory of the future. One of the main factors of cybersecurity is the human behavior and the human factors. So we welcome now Dr. Zenaida Benenson from the Lab of IT Security and Privacy at the FAU, and she leads the group Human Factors in Research and Privacy. So the stage is all yours. And
speakers. Yeah, thank you. Okay, so cybersecurity. I work at FAU and I lead a group for human factors in security and privacy at the Lab for IT Security Infrastructures. And my passion is for evidence-based security. And this is like evidence-based medicine, which means you use all available evidence, like data. You also look at values of the patients, and then you decide on treatment. And I would like to have the same for cybersecurity, and I'm going to give a couple of examples. Could you please start the clock, because so I can see here how I don't want to, you know, like to take too much of your time. Okay, thank you so much. So passwords, everybody. So first of all, I have a task for the audience. Please think how many password-protected accounts you have. Is it 5? Is it 10? Is it 20? Or is it more than 20? And if it's more than 20, please raise your hand. Okay, almost everybody. Yeah? So it's something that all of us are using many times of the day, but the evidence-based password management only emerged maybe 10 years ago, and only was transferred from research to the practice a couple of years ago. And let's look at this. So you can see these passwords. Yeah, they seem to be quite complicated. And yet, yeah, so they have special characters and everything in them, and yet they could be cracked with a single computer, like in a couple of hours. Why? Because they were stored insecurely. Yeah. So just imagine all these people who really tried to get a strong password, and then it was useless because the provider did not store the password securely. And as I already said, yeah. So imagine all this effort for all your accounts. I know that nobody is doing this. I'm also not. Yeah, we all reuse passwords and so on, but we shouldn't. Yeah, according to the established wisdom of traditional password advice. Where does it come from, and is it evidence-based? Well, it comes from this publication of National Institute of Standards and Technology in the USA, which is used for as de facto standard in many countries, including Germany. So it's not used directly, but the guidelines that for cybersecurity are often based on this. And it was from 2003. And please just note that the first author is called William Bohr. And let's look what happened in 2017. The headlines at this year were full with Bill Bohr apologizing for his for this guideline, where he and his co-authors wrote that a strong password should contain all the special characters and stuff. And, everybody was so happy with that, everybody, so all media quoted him, and, and you can see how really annoyed people were about something that were not evidence-based and actually not humanly feasible. And another thing that I'm sure you are confronted on a regular basis is change your passwords regularly. And there we actually have another piece of evidence, which is one of my favorite papers by American colleagues. So what they did, they had access to expired accounts of a university in the US, where passwords had to be changed every 3 months. What did they do? They developed an algorithm that guessed password of a person, giving one password of this person. Yeah. So if you know one password of a person, you can guess others in 5 tries in 17% of cases. And, like in 3 seconds, automatically in 40% of cases. And we have heard that the speed of, computation is growing. So it was in 2010. Okay, so we have evidence that password change does not improve security, and it actually makes it worse. Why? Because when a person did this creative task of creating a really strong, good password, they had to memorize it. And then 3 months later, they have to change it. Oh my God, yeah? It's a lot of creativity went into this password, and a lot of effort went into memorizing. What they do, of course, they just, change it minimally. Yeah? Okay. So, 2017, NIST, giving all this evidence, created new password guidelines, which say that the users have to create passwords that are 8 characters long, and that's all. Yeah, it's a huge difference. Thank you. Thank you. But there is, of course, like you can't get security for nothing. As there is more work for providers. So who are security experts? And they have to to compare newly chosen passwords to lists of very simple known passwords and rule them out. They have to store passwords securely and also some other technical stuff in which I'm not going to go yet, which means more work for security experts, less work for the users, and that's what I call like valuing the values of the actual users of technology, where we come back to evidence-based cybersecurity. Okay, next thing is also something that you know very well. It's clicking on things, also called phishing. So you receive emails sometimes with dangerous links and attachments, and as you click on it, your computer might get infected with a virus, and there has been cases of, for example, like hospitals or organizations, factories, universities getting all the data encrypted by criminals. And it started just with one click on such an email. And this is a danger that all of us live with. Yeah? And so and quite often people ask me, can we somehow prevent it? Can we somehow train users not to click? And my answer is, I wouldn't go for that. And I'm going to explain why. So, I don't know if you have heard of this RSA security breach in 2011. So RSA security, so who have heard of it? Could you raise your hand? Oh, great, okay. So this was a real thing. Say criminals broke into their networks and stole confidential information about the security token that you can see here. It's Secure ID, which was used by a lot of customers all over the world, maybe also in Siemens. Ah, okay. Okay, yeah, I think you're on the safe side right now, but 10 years ago it wasn't like this. And now we know more or less the full story. Why? Because everybody involved into this breach had to sign a non-disclosure agreement for 10 years. And now, 10 years after that, some stories appeared in the media. And how did this thing happen? Well, the criminals sent an email to 4 employees at this company. 4, yes, imagine. It has subject line, recruitment plan, and the text, I forward this file for you for review, please open and view it. Yeah, very simple. One single employee in Australia retrieved this email from the junk folder and clicked. This file contained an unknown vulnerability that could not be caught by antivirus, and so the criminals got their foot into the company and then infiltrated using this computer of an employee in human resources, infiltrated the whole network. And yeah, very obviously, many of you know what happened. Secure ID got hacked, and RSA spent around $70 million on the mitigation of the attack. They had also to change all the 40 million tokens that they issued. And, well, they are still in business. Yeah? Let's say that. But what also happened is that US defense contractor Lockheed Martin was attacked using this technology because they used it for authentication, and it's not known what it's known that criminals tried it. It's not known if they actually what they actually stole, and on which data they actually could exfiltrate. But this was the actual target of the attack. Okay, so very obviously clicking on things in one click is dangerous. What can we do about this? I don't know yet. It's my research topic, one of many. What we did in trying to understand this, we did a user study at FAU where we recruited students under a cover story of like asking them about their internet habits, I think, in a survey. But instead of the survey, we sent to them this message. 7 days after New Year's Eve celebration. So we targeted this at students. We thought, okay, students would, maybe spend their time New Year's Eve day on the party and so on. And it contained a simulated dangerous link, so which was individualized, such that we could see who clicked and who did not click, and if they clicked, they just received access denied messages. And those clicking experiments are conducted all over the world all the time. Maybe also Siemens is doing this. No? Yes? You don't say. Okay. And that's not my point at all. Yeah. Well, clicking rates are a bit scary. Yeah, especially when this message was received via Facebook, so like 40% clicked. But that's not my point. My point is that after that we asked for reasons. Why did they click? And this is very interesting. So I have some quotations from the explanations. So for example, I wanted to see the pictures out of pure curiosity. Yeah? Wanted to know what would happen. I thought the email was from a friend, so they thought that they know the person. It was we sent it from unknown, of course, non-existing person, but using top 10 names in the generation of our receivers. Yeah, first names. Some first names are more popular than the others, and yeah, so quite a lot of people thought that they know the sender or might know the sender. Or there was some interest in the pictures, and it could have been from people on my party. Yeah, it was plausible, and some people wanted to investigate. Yeah, what happened? Why did I receive this email? Could I recognize somebody on the pictures? Yeah, it's also absolutely legitimate reason. Or they thought, okay, nothing can happen because it's webmail of the university. Yeah, so this is something that also happens a lot in companies where people would behave more dangerously because they know the company has got IT department and they would help. Yeah. So, okay. So what are the reasons? Curiosity, plausibility of content, known sender, trust into technical context. This is everything that we also do when we decide, is it email legitimate or not? Yeah, and this is very plausible reasons. Yeah, so what else should you do if you are deciding? So the question is, could this happen to you? And I don't know, but it certainly could happen to me. So look at this. So I received this email when I was trying to set up a contract with a company for security audit of a product. Yeah, so this is product X, and somehow it didn't come out. So half a year after the last interaction, I received this email from the manager I was interacting with. It had right product in the name of the attachment and also in the name of the of the email. And I almost clicked. It also had right signature. And then it occurred to me, wait, last week I was telling my students about this phishing experiment. Should maybe look at this again? I looked at this again, and it occurred to me half year after the, this happened, it's quite unlikely. And this manager never said mornings, so he usually addressed me by name. So the next thing, I ran out of my office to a colleague who also was involved, yelling, "Don't click on it." He looks from his screen and says, "I already clicked." So what happened? Nothing happened. My antivirus went up. Okay? this was a colleague working for many years very successfully in cybersecurity. This was a plausible, and I mean, it also would happen to me if I wasn't reading this lecture about phishing just at this week, a week ago. So it can happen to anybody, I think. So, and the awareness requirements on the users, if you want them to be aware, is to be suspicious, basically, of everything at any time when you see an email. And there's a question, is it feasible? We know that remembering 20 strong passwords is not feasible. You don't need a psychologist to explain this to you. What about this? Well, there is a book written by a Nobel Prize winner in economy, Daniel Kahneman, Thinking Fast and Slow. Maybe some of you have read this. And he says that there are two ways of decision making. System 1, which is thoughtless, intuitive, and System 2, which is rational and effortful. And we can be in both of these decision making modes. So System 1 is characterized by good mood, creativity, intuition, and gullibility. They go together. System 2 is characterized by vigilance, suspicion, analytic approach, bad mood, and increased effort. And they also go together. So if you want people to be vigilant all the time, they would have to be in System 2 all the time, and that's just infeasible because we usually operate in System 1, and we need a trigger, like it happened to me, to change to System 2. And reliable triggers is, for example, something that we are investigating now in my research group. We are also very welcome cooperation by companies on this topic to get more evidence. And to summarize, what does it mean, evidence-based, human-centered cybersecurity? When you design a cybersecurity measure, you should ask a couple of questions. For example, what do you want people to do? And will they be able to do that? Will they be able to remember all these passwords? How to gather effectiveness evidence? Does it really improve security? And how can we measure negative side effects? Like in medicine, of this security measure. And maybe the last but very important point is expect mistakes. Humans will make mistakes even if they are highly trained in security aware and everything, and be prepared. Thank you.
So thank you so much for the great keynote. Do we have any questions in the audience? Okay, then I will have it. Okay, yes.
I think you want to repeat the
so
question.
we're talking more about the technicality of phishing and.
Okay, so the question was is it possible to have some technical measures? And of course, it is possible. And there are some technical measures. So, for example, you have spam filters that work with machine learning, and they are great. But of course, they have false positives and false negatives. And so false negative means something dangerous is not recognized, and false positive means something not dangerous is recognized in danger and removed. And now, and this is a problem, for normal users, because they don't want anything legitimate removed. So maybe sometime, like AI would get so good as to recognize 100% of deceptive emails, but it's not so good yet. And what you mentioned, there are also possibilities of safe viewing of files, for example. So you click on it, and it shows you some warning that, well, don't activate macros. And now guess what happens? Of course, everybody activates them every time. Yeah? And this is bad, user interaction design. Yeah? And this is, for example, something that we would like to get better.
Did that answer your question? Perfect. Any more questions from the audience? Okay, I would have a question, and that goes into the remark of human factors. So in order to mitigate, you said passwords are not the safest thing. What do you think is the future of biometric security?
Future of biometric security is great, I think. Okay, so let's differentiate. So you can have biometric data locally, for example, when you authenticate to your smartphone. And this is great. I find it great. But when you have to authenticate, say, for a web service, and this would mean that your biometric features are stored somewhere in some cloud. And nobody knows what's going to happen to this cloud and when this data is going to leak. And at the point it leaks, you can always choose a new password, but you have only 10 fingers and 2 eyes. And if this leaked, you will, you will have a really big problem. Yeah. So for local authentication, great. For remote authentication, I'm a bit skeptical.
Mm-hmm. Yeah, I recently read about an example where, in order to enter the company's buildings, rather than using cards, you can just scan your hand and then you're allowed to go in. Seems like a safe way of traveling.
It's a very usable way, yeah. And
yes.
But
yes,
it
I would
work.
be skeptical if it was also my password, face recognition, for example. Someone can just take a picture of me and then show it and get through. All right. So there will be no more break of the time because of the time. And so I would like to thank you once again, Dr. Benenson, for such an insightful keynote.
Thank you.
Please. Thank you. So we will now hear about the future of our research. Okay, we take a little minute to get ready. But while we're waiting, we will now hear shortly about our research and innovation ecosystem, Erlangen-Nuremberg. And I would like to start by saying that great research and powerful innovations require strong partners and great network. So we are already excited about the new approach in university and industry relationships. Natascha Eckert, the Global Head of University Relations at Siemens, and Catherine Moslein, the Vice President for Outreach at FAU, will reveal to us today. So the stage is all yours once you're ready, and you can join us now. We will also be showing you a short film in a minute, so lots of interesting things coming forward. A little look on the agenda after the film and the moderation of the event of the research and innovation ecosystem. We'll also hear from the startups, and we'll also held a discussion with Benjamin Zohoff. Perfect. Thank you.
Working in the Siemens research and innovation ecosystem will increase the number of opportunities for both organisations to address global challenges in digital and engineering areas.
Inspiring and enabling people to unleash innovation potential.
Being part of the gold standard in industry-academic collaboration.
Working in innovation allows us together to deliver real impact, not just for both parties, but for the university, the region, and the country as a whole.
to engaging and exciting tech challenges from anywhere in the world and learning from the best.
Being very close to the universities.
It's a fantastic opportunity to champion efforts to advance the state of the art in the field of simulation and digital twins.
This exciting initiative will be critically important for us to foster meaningful interaction.
To bring together the brilliant minds of the world.
Bringing genius minds together.
Reaching out to the public.
To solve both today and tomorrow's societal challenges.
Bringing together talented students, inspiring researchers, and ambitious entrepreneurs, together with leading experts from Siemens, to unlock the power of open innovation.
And together, create and innovate to make real what matters.
Pushing innovation to the limit with all we have. And last not least, enjoying Austrian food across borders.
Means the opportunity for broader collaboration and projects to help improve research efficiency and effectiveness.
Living the open innovation spirit in one of the most innovative regions in the world.
And co-creating the future in open innovation projects.
That people from different disciplines and with different ways of thinking interact in a cross-organizational environment.
Pooling excellent skills and forces from various disciplines regionally, connecting them globally.
So that they can jointly develop new ideas and products to make the world a better place.
Our research strengths complement Siemens' core business, and we look forward to making scientific and technological breakthroughs together.
By transforming new ideas into reality through collaboration with such organizations like Siemens.
It's a unique opportunity to foster collaboration across industry and academia, but also to accelerate both innovation and the development of the workforce of the future.
This stimulates creativity and innovation, and it fosters the startup culture.
Building a more resilient and sustainable future with our global partners.
The best and most renowned stakeholders in the region coalesce with complementary strengths to deliver impact and grow together.
We are part of something bigger. We are connecting talent and knowledge across the world to make a positive impact on society.
In short, true open innovation.
We are thrilled to partner with you. Thank you.
So I hope you all know now who is the most innovative region in the world. Metropolitan area, Erlangen-Nuremberg. So I'm quite proud to see and watch all the voices out of our new Siemens Research and Innovation ecosystems. I think you already have figured out that CKI is no longer here the brand. So we moved from a more university-centric approach to an ecosystem approach, though the new brand are the Siemens Research and Innovation Ecosystems, the Siemens RES, so that's much easier as the CKIs, especially for the president here. Now you can see how we spent the pandemia. So we really just try to reinvent and review the past or the former program of CKIs and principal partners has been the 25 strategic partner of Siemens, a global network, but as I mentioned, very university-centric. So after 20 years, we thought it's time a bit to adapt also to the developments in the outside world. And I think I don't have to explain to you as members of a universities that universities are more and more working in ecosystems, in innovation ecosystems. They partner up with other research institutes. They have more and more international alliances with the universities. And most of them also start their own startup activities, have tech incubators. And also on the Siemens side, you could see popping up the name ecosystem a couple of times. So also we need the stakeholders outside. We need universities, research institutes, startups to really foster innovation and drive it globally in a big network. And I think co-creation, co-location, for me, it's not the future, it's really the new normal. I would say we are here today in Joseph's. We inaugurated Zollhof last year. This year we inaugurate together Joseph's. We also heard that the societal and the technical challenge can also only be tackled by interdisciplinary approaches, by different stakeholders, different perspectives. And we need the startups to drive innovation or bring innovation faster to the market. And last but not least, we also want to attract really the best digital talents, not only from one university, but also in the regional ecosystems. I'm very proud, we heard this morning in our steering committee, that the employer of choice, Siemens, is not only ranked number one for the engineering students, but this year for the first time also for the computer science students. So I think that's a big move for us. It shows that we are seen in the meantime from the students' perspective also as a digital company. So this is what makes us very proud. Coming to the Siemens Research Innovation ecosystems, we have 16 of them, a very global setup, and you can see coming from the Erlangen-Nuremberg ecosystem, you really play in a league from, let's say, pick out some from Greater Boston area, Oxbridge are covering Oxford and Cambridge, the Zurich ecosystem, can I say Munich? I can mention Munich, right? Munich ecosystem or Berlin, and the Beijing ecosystem. And we are very proud of that. For the first time, we also have an Indian ecosystem in place, so we'll also drive research innovation in an ecosystem together with our colleagues in Bangalore. All the 8 CKIs will be lead universities of 8 of the ecosystems. We also will have other lead universities, and that means that we, together with the lead universities, we will shape the ecosystems in future. It shouldn't be about competition, maybe a bit always, but not too much. It really means collaborating also between the 16 ecosystems. So Erlangen-Nuremberg, maybe Bangalore, Katrin, we already talked about, but certainly also the Bay Area. So that's, and you are the co-shaper. Maybe I can tell you a co-shaper, Katrin. So together with you and the whole FAU team, we will then also shape the new Siemens Research Innovation Ecosystem Erlangen-Nuremberg. And I click on your slide?
Click. Thank you so much, Natasha. And I think you all have already seen how enthusiastic I am as an open innovation researcher about this move to an ecosystem, this approach to ecosystem thinking, to ecosystem working, because ecosystems are highly interactive, agile, inclusive, and they include a whole range of quite diverse stakeholders. And I think this is what we experience in this room, this is what we experience today, that innovation happens so much across boundaries and between players that would have never made standard contracts and standard exchanges. So this opening up among all these ecosystem partners, ecosystem stakeholders, is a real step forward and changes the way how we interact. And I think we see it in many dimensions, and you see what makes such an ecosystem, so 16 ecosystems. Each of the 16 ecosystems has a lead university, and for sure FAU is super proud to be the lead university, but working together with the strong research and innovation partners in the region, the Fraunhofer IAS, Fraunhofer ISB, the TH Nuremberg, all our partners in the region, with the startup scene, we have already mentioned Zollhof, and. And today's focus really shows the local specialty, one of our local specialties with Factory of the Future and the focus on automation. I think this is something that's very unique. And I don't want to go through all these aspects, but I want to say a very warm welcome to our friends and colleagues in Bangalore who are connected with us today. They are watching, they are active already on social media, like many others around the world. And it's great to see that happening. So it's not a kind of star alliance, it's a close network of interaction and exchange. So maybe let's move on. This is what we see here. And this is also a big step, because usually companies focus and put their own logos in the center. No, Siemens enables, facilitates an ecosystem worldwide. And it puts lead universities on stage and gives them a role and responsibility. So now FAU is in the role and the responsibility to facilitate and orchestrate the Erlangen-Nuremberg research and innovation ecosystem jointly with Siemens. And you see all the partners, and I don't have to go into depth. It will take time, and we should take the time for our exchange and interaction and not for front-loading with information. So I think you get the impression of what it's all about, what we want to drive, what we want to move. Moving knowledge, FAU, that's what we have in mind together with all of you here and on the screens. Natasha, there's more to say. What do you see as a new, or do you have an example how it changes?
Yeah, I think we give the stage to the new example. It's a startup, interestingly caused by a PhD student coming from Siemens, having an idea, wanted to make his PhD, and then he dressed Katrin. So that was interesting, and Katrin, you can go on the story.
Well, I already mentioned in the break that one day, one of my postdoctoral researchers said, hey, Katrin, you have to go with us on a coffee. I want to introduce to you Peter Schopf. And that's how we met. And after that inspiring meeting, I somehow lost my postdoc, for sure to Siemens. But I won a new PhD students who did not leave Siemens, interestingly. So we have those different models of cooperation, and you made changes happen. So please join here on stage and tell us more about what you are doing in between our institutions when you are not focusing on your PhD.
Thanks a lot. Yeah, thanks a lot, Katrin. Just briefly about myself. In Siemens, I'm head of sales for MindSphere. So MindSphere is the open and industrial IoT platform for the industry of things. And that by itself is quite interesting. So because I'm involved day to day in things of platforms which work and don't work. But writing my PhD, I do about augmented reality. And I don't have much time, but I want to talk about the 3 maybe most important days of my life very quickly. Because one of the most important days of my life actually was meeting Katrin in Erlangen together with my supervisor, Julia Jonas, and that she agreed to all my ideas around augmented reality and what I can do with that, and agreed to host my PhD so that I have the chance making a life dream come true, going more into science, understanding science, but also putting my vision on a stable basis. And where did all this vision come from? And there I need to move back to another, probably one of the most important days of my life, which was in 2017, having a 10-minute pitch in front of Roland Busch back then. And afterwards, he gave me a quite significant budget to explore my ideas around augmented reality, quite freely as well. And that gave me a notch, because before I had a quite successful career in commercial realm, and this gave me the opportunity to move into software. And why moving into software? Because I want to change things. I want to drive things. I want to have an impact on the world around me. And I think I can have that with software. So what I found out during that project was that augmented reality will be the most intuitive way to interact with localized information. And that has a huge impact, because everything that is most intuitive will prevail above everything else. So I'm confident that when the technology matures, in 10 years' time, we will all be very impacted by augmented reality in the industry, but society as a whole as well. And now when you have that knowledge or that conviction that augmented reality will change the world, what can you do about that? You think about science, obviously, how to address that with science, but also how to address that for our company. And that brings me to the maybe most important day of my life, today. Because today, actually, I have the possibility to explain where we stand. Roland Busch already agreed that he will spend 5 to 10 minutes with me afterwards, where I can pitch my vision again, where we are currently addressing Professor Franke's challenges to us of where to place ecosystems. What kind of ecosystems can we generate? Because I'm convinced that we as Siemens have a very big shot here creating an ecosystem. We also have the app that we created during the last years with us, But it's not so much about the application, which you all can then test later on, hopefully, at least artificially. It's more about the concept, combining different knowledge systems together with one interface to the customer. It's not so much about the app, it's more about the vision of what we can do as Siemens with that and about the strategy of how to get there. So for example, one of the big parts is the open innovation ecosystem. We already agreed, Mr. Hornegger and I, in the break, that we will soon have an augmented reality campus app for the FAU, hopefully powered by then Siemens technology. And the open innovation ecosystem that we generate will be including many more, and we need to be open here. And we started that quite early as well. Already I approached, actually also facilitated by university relations, which brought me in contact with Julia Jonas at the very beginning, so we had a long story as well, brought me together with the Digital Tech Academy, and Lucia, a very important part of the start of our open innovation ecosystem here. And Lucia, together, we started and developed a startup. Was not an easy time, but now it's finally, it's there. I'm very excited about that. And Lucia, please tell us what's the role and goal of Arfinity.
Yes, hi. It is very nice to be here and to see all of you. So Arfinity, we are an AR startup. We focus mainly on the world of trade fairs, so a little bit out of the Siemens core business. We are developing an AR platform. Like we heard before, platforms are the future, which basically consists of two modules. On the one hand, you have the self-service tool for exhibitors, where they can create their own AR content, especially, for example, in machine engineering or plant engineering. You have very huge exhibits. And we are facilitating that the exhibitors can create their own AR content. And on the other side, there's a second module, which is an AR app, with which the visitor can view all content of all exhibitors in just one trade fair-wide app. And this app is also based on, or partly based on HoloLayer technology. I would tell you a little bit about, because we're talking about ecosystems, how were we involved in the ecosystems here in this area, what was our story in that sense. So we actually have our roots in the university. We started off with the Digital Tech Academy, as Peter mentioned, where we had our first contact with the startup world. We built a lot of business models. We found ourselves as a founding team. And then through the approach of Peter with the DTA, we actually got in contact with the HoloLayer team. We worked together for quite a bit, and we noticed there's a very interesting use case outside of Siemens core business. So another business unit got involved, which was the Siemens Technology Accelerator, who also supported us through the founding phase, which was a very exciting phase for us. And as I said, as to this day, we still use the HoloLayer technology in the app part of our solution. And we still try to have a very good cooperation. As you can see, we're here today together. We're also in talks, for example, about joint developments. So we're still trying to establish a good relationship. And another big part in our journey that was quite recent, also mentioned today already, the Zollhof. Zollhof is a tech incubator here in Nuremberg. Two of the main partners are Siemens and the FAU. And there we got another additional help from like a very good institutionalized, enriching part of this ecosystem. Why am I telling this to you? First of all, I want you to understand that startups is a lot of chances, a lot of sometimes luck. We are quite a good example how it can work. We have our roots in the FAU, we have our roots in Siemens, but we're also quite a curious case in this sense, because most startups don't have as many opportunities as we do. And for me, it was really interesting to hear that there will be put effort into growing and strengthening the research and innovation ecosystem. And I just hope that in the future there will be as many opportunities or even more as we had for other promising startups, and that Siemens and the FAU will also play a big part in it. And of course, you can later try out the app that we brought here together today and experience a little bit of augmented reality.
All right, thank you so much for the nice discussion here. Do we have any questions from the audience? Anyone from the online audience? All right, yes?
How will you move to build this holo campus for FAU?
So just to repeat the question, how will you build this holo campus for the FAU?
So hopefully I have a successful pitch with Roland Busch later on, and he will give us possibilities to extend our capabilities. And then we will talk to Professor Hornegger about how we could imagine doing that. And then we will ask Affinity, hopefully, to host the whole thing for FAU. And that's the current goal, at least. So let's see if that works out.
Thank you for the question. Yes?
I have another question, as we do similar things in our department. And the question I would like to raise, what's the business model behind?
So what's the business model behind?
That's a very good thing. I would love that you join maybe my pitch to Roland Busch. Yes? No, it takes roughly 10 minutes, and 5 to 10 minutes, for sure. And it's a very good question, because augmented reality as such does not bring a lot of value. Yeah? It's an interface. It's an interface to what else you got. And that's important. And every Siemens unit will start looking at augmented reality solutions. So what I want to achieve is that we do not all start independently, like you already pointed out that you start in that direction, but we rather combine our efforts, and not only across Siemens, but beyond. And that we generate one augmented reality solution for the industry, instead of each building their individual solutions. So that's the idea.
And what is yours?
Our business model is having a platform, as I said, for trade fairs. It also works for events, but we identified the trade fair market as a very profitable market for us, especially now after Corona. Our customers will be the trade fair exhibitors. We will work very closely with trade fair companies like Nuremberg Messe, Fruit-Solho, for example. We got very close contact with them. It will be a software as a service solution, where the exhibitor pays for using this AR pipeline to create and exhibit their content on the trade fair-wide platform. So all the content that will be created via this self-service tool, you can of course use it to create a digital or completely virtual trade fair. And in the long run, you will maybe see later when you look at the app, you have kind of a scanning of the surroundings. So in the long run, it is to place the models. In the long run, it is possible to maybe create fully virtual rooms. The technology is there also already today, but this is not our main focus right now. It has a lot of future potentials, of course.
Thank you so much. Any further questions? All right, then I would like to thank you once again for sharing all the information. And now we move on to our next keynote. So startups are at the forefront of innovation, like we just heard today. We have two very exciting startups for you from the ecosystem Erlangen-Nuremberg. And I'm very excited to call upon stage Dr. Eike Schäfer from Robotop, and he will introduce us new methods to virtual reality-based factory planning. Following his panel, we have another startup, and where we will see Sasha Julian Ox and Dr. Max Jolowski, who will introduce us to QuartRevo, that will change your perspective on how you learn about Industry 4.0. So the stage is all yours, and here you are.
Oh, thank you. So thank you for the kind introduction, and can I also get the timer, please, so I also get an overview over my time? So thank you. So it's about Robotop. It's about a story about university, because we started at university. So I started as a student at the FAU, and then I did my master degrees here. and I have lectures by Professor Franke in digitalization, automation technology, and also by Professor Vogt in entrepreneurship. And that's also the reason why I went to FABS to do more digitalization. So we won 2014 the research project Robotop and started our research journey. Afterwards, we got a completed research project, but what's next? So next is what you see, Exist. Exist Foundation we started in October, and now we begin our journey as a startup. But what's the problem? First, I want to paint a general problem, like corporate communication. So corporate communication is somehow like that. A lot of people talk to a lot of people in a lot of meetings. And then more people come, more communication, and the more you talk, yes, the more complex it gets. And so we have a lot of communication and a lot of talks with a lot of meetings. I don't know if it sounds somehow familiar. And so what's the problem? Problem is, on the one hand side, a lot of people are involved. It's important because we have complex products. On the other hand side, the communication is more text or email, and it's hard to understand for people. So hard to understand. Some manager told me we have 2-hour management meeting, and then one guy showed 1-minute video, and every discussion was finished. So if the information situation is clear, and like if you're buying a new house or stuff like that, and it's a very good deal, you don't have to discuss. But if you buy something which is vague and you don't know what is the use, then it's very complex and the deciding takes a long process. So our goal is to reduce this effort, to make information situation more clear and to get a more precise communication. But why is it important? As you mentioned, automation is very important. And also the market is showing it. Robots, the market is growing. And you have a lot of billions just for the robots and another more billions for the automation technology around the robots and also for the services. But one thing is, clear. SMUs are lacking. So small and medium-sized companies don't have a lot of automation solution. Only 3% for small companies have automation. And what's the reason? It's very complicated, it's very expensive, and it's not mass market ready. So if you are an OEM or a big company, so you can easily do it because you have like the business case, the business value, but for small companies, business value isn't so clear. And how does the cost split? So in automation project, you have like about 50% hardware and 50% services. And within even engineering services and project management takes a large part of the costs. And the reason is we have a lot of information loss, we have a lot of complicated information. And so how could we make it better? Better, we could make it like not every time reinventing the wheel. We see a lot of engineering, they're enthusiasts, they like to build new technologies, but everybody is reinventing the wheel. So if you stop reinventing the wheel, it could be a real use case. Also, Pareto for engineering, so a lot of we start from scratch. We start from zero, building up automation technology. Why don't we use old projects, data as mentioned, and start engineering projects from top down? And also a platform could support like loss of information. So to summarize it, on the one hand, we have like customers who need more digital interfaces and also to reduce the demand or to reduce the effort for demand creation. So if you talk a lot with your sales force to the customers, then you have to, like, it costs a lot of money. If you reduce the time your sales force has to talk to your customer, you can get to touch to a lot of more companies. And that's also why SMEs are not a business case for huge automation companies. On the other hand, automation is too costly. Small companies don't have the business case. They don't know about automation, so a lot of consulting have to be done to sell them something. and also they don't have the business value or business case. So a lot of sales of automation solution tell the customer have to know his business case, but if you're new, you don't know your business case. The specialists have to tell this project was very lucrative for another company, so it would be probably also for you. So here also there's a restraint. And so we want to improve that. How does a typical interface look like? It's like you have a website. You click, and then a long process starts. We want it more interactive. We want to have it in 3D. We want to have more usability, more easiness. And that's how we start. So our journey is very easy. We select the 3D best practice. We configure it on a basic level, and then we match orders. And that's all the stuff. And you can do it with a lot of best practices. So analyzing the data on the market, you can just look for a lot of best practices of different industries. So we have quite a lot of experience preparing this best practice data. So if you're interested in, then we support you to prepare your best practice data, even for internal communication, then contact us. And this 3D best practices we use to get the top-down configuration. So we also validated it. So we did like the best practice configuration process, then adapted it with a system integrator, and then made a virtual commissioning approach with high-tech. So as you see, we reduce the effort even for the later phase of engineering on a great base, because we gave the system integrator the best practice data, and he don't build everything, every concept from scratch. And so they said 40 to 60% less effort, even for virtual commissioning using best practice data. So what we do, we connect solution providers and customers. Solution providers we support in building up these best practices and make them configurable and put them into the ecosystem. Providers we provide with the necessary information. We match things that exist. So one system integrator told us, if we can sell scalable one solution we build in one factory to a lot of other customers, we reduce the engineering effort. So by reducing this engineering effort, also a lot of expense in the companies could be saved, even by scaling this, and also to get more a mass product out of a special machine. And secondly, we support the communication. So 3D webinars are possible. I will show you a little bit examples soon. And also like training. So we also have to think in more scalable ways, even for SMEs, because you can't send one person to every SME. You do it in a more scalable way. And also education institutes. So why don't Siemens give like this 3D best practices, for example, to the university, so you can teach students, so you can export out of your interim material, training material to universities, and so get also more leverage. It also could be used for internal communication. So we have our 3D best practices. We combine it with a 3D scan. You can do it like with new smartphones like the iPhone 12 Pro. There's a quite good LiDAR scanner within. And combine it with company-specific templates. And then you can export it to a lot of different company parts. So marketing, sales, trade shows, you can all export out of these with some templates. And like we had an upgrade of FAU logo, so a lot of PowerPoint people are now very happy to upgrade the slide masters. And so, yes, it's also like, it seems less, but it's a lot of effort. So if you reduce that effort, it could scale even internally if you reduce management and overhead cost and reduce the stupid work nobody wants to do, like to click and to put things consistent. This is what a platform can do. And also for other parts you can use it, even Xing, LinkedIn, or even to push it on the Robotop platform. So to get you a touch, look and feel, we also have seen it in the presentation of Professor Franke, it's like you select a best practice, then you can have a look in the virtual commissioning environment, 3D scan, so it's a FABS environment of Erlangen. We scanned with a smartphone combined with the best practice, so you can just see it in the real environment. then you can create a proposal out of these. So to get in contact with your customer, to automate this process, and also to get a track of the process, where and which stage I'm in. And lastly, you can also make virtual plant simulation trainings, so we can export this to virtual trade shows and so on. So you can also reuse the content for training and also fairs. So that's our team. We got the Exist Foundry. I finished in March this year my PhD on this topic, also on Robotop at Professor Franke. And we would happily invite you downstairs to our demonstrator so we can have a look at the parts. And we are happy to discuss with you to get feedback from industry, how we can improve our business models and how we can scale maybe together. So thank you for your attention. We did also a lot of research, so if you're interested in this, you can also find it here. And now I'm open to questions for later, but now I give to Sasha for the second pitch.
Thank you very much for the kind introduction, and hello from our side. We are QuartRevo, a spin-off of FAU, and we are really excited to talk to you about our approach to digitization today. So, digitization is one of the megatrends of our time. It offers the potential to solve problems that our societies face, but it's also a question about the how and what for. Many technologies developed and matured over the last years, artificial intelligence, cyber-physical systems, big data analytics. But when it comes to what to use it for, there are still many questions. So companies ask the question, how can we apply this technology? How do we align it in our brownfield surroundings? How do we integrate our stakeholders? And also what for? How do we develop goals for our digitization strategy? What kind of ways do we got to make money with it? What is the right business model? Do we have to innovate this? And why these questions are very important, I would like to give one example. Does anyone know what this is? It's the Apollo guidance computer. This was used in the 60s and 70s in all Apollo missions flying to the moon. And I'm really into space exploration, and I really like to have this on my slides every now and then. And this computer was able to conduct 41 calculations each second. And here we have the brand new iPhone 13. This device can calculate 15.8 trillion operations each second. So what this device can calculate in 1 second, this one would need 12,000 years for. But yet, let's take a look where these devices have taken us. The one has taken us to the moon, and the other one, well, I know, this example is exaggerating a bit. But it still shows it's not just about powerful technology, it's about its application, its context, and especially enabling the users.
So then, let us now build a bridge to Industry 4.0 and how to come from vision to application. Because there are many technology-based visions out there, but it's often not so clear how to get them really into application. And the problem is often there's no one-size-fits-it-all blueprint that can be applied in every company, and custom development is required there, and that's where our solution is coming into account. And the question is, how can we get to help you to get the top to master Industry 4.0. And we put up some set of measures. Not every measure is required for every customer, for every client, but for us it's really important to bring all stakeholders together, because when bringing stakeholders together, you have some people from diverse backgrounds, and that's a huge potential for new innovations and developments. And there it's important that every stakeholder has the same understanding and the stakeholders can speak a common language. And that's basically what we do in one of our first steps, try to uncover and resolve fears and rejections, for example, by demonstrating technologies and application scenarios in an easy-to-understand way. And what's always important for us also to excite and educate people. And how do we do it in practice? We've developed a systematic, methodical, practice-proven, and research-based path consisting of 4 steps. And therefore, we use 3 different web tools in one demonstrator. And that's what we talk about in the next few minutes.
Yes, let me introduce our first web tool we've got. It's the Industry 4.0 Compendium, and it's a web tool where you have basically a library of topics and themes that are important for Industry 4.0 in digitization. We go into the potentials, into potential issues, we go into architectures, the integration of humans into systems, and we've built a categorization. You can see we have categories, we have subcategories, and so you can use this tool to basically get an overview about this entire topic. And when you click on each of these little bubbles, you will get information. The one thing you get is scientific papers, which are from extensive literature reviews. We collected best practices from the industry, so you can see how others are doing certain things already. And lastly, you also get information about publicly funded projects, because all the results of these projects are free available, so you can gather information on technology, services, and other relevant things regarding Industry 4.0. As Max already mentioned, we approached the topic from a very stakeholder-centered perspective. And therefore, in over 36 hours of interviews and focus groups, we talked to all kinds of stakeholders, both from inside industry, but also outside. So we talked to managers, we talked to the workforce on the shop floor, we talked to unions, we talked to workforce representatives, universities, etc. And based on the results of these interviews, we came up with stakeholder cards. These stakeholder cards are basically profiles which show the attitudes and expectations from these groups towards this topic. And we also asked each stakeholder group to talk about each other. And based on these results, we came up with a matrix which shows between what stakeholder groups we have to expect conflicts. So here where it's red, these groups were not talking so nicely about each other. And therefore, you know what kind of stakeholder groups when you have them both in a project where it might rumble, and we also provide measures how to resolve these conflicts.
And the next tool and the third step is our Industry 4.0 application map. This basically clusters common Industry 4.0 applications and clusters them in application spheres such as industrial smart services, smart factory, product-related smart services. And this tool functions somehow like a typical Canvas tool where you can combine the results of the 2 previous steps. And then you get a system configuration, as we show it on the right side of the slide. This can look a bit like that. And important in this step is also to do a first cost estimation. So how many money do I have to spend for implementing a certain application? The fourth and last step is our Industry 4.0 demonstrator pit for CPS. There we basically shrunk a complete smart factory to fit onto 3 to 4 standard tables. And we can demonstrate quite a lot Industry 4.0 applications and technologies such as additive manufacturing, augmented reality, and also applications for artificial intelligence and many more. And this all on standard meeting rooms and on standard tables. And today we brought some of our core modules and put it in the back of the room. And we're really looking forward to showing you some of our application scenarios and technologies later on, and also together with HoloLayer and Affinity, we put some small collaboration today. And I'll close my part with some workshop impressions where you can see our shrunken smart factory interacting with the broad public, with politicians, public authorities, and we do it also a lot with students, and we did it also with children, and everyone was really enjoying the tool, was really losing some fear of touching something or was interacting with it, and emotions were triggered, like the guy on the second picture, for example. And it always excites and inspires people.
Towards the end of our presentation, I would like to show you our service offering. We have 3 main groups that we target with our offer. First, companies and organizations. What we do is strategy and technology consulting. We help to develop digitization strategies. Then, stakeholder integration, bringing together all the relevant people, the users of a system, the workforce that has to apply certain measures and develop a system together with them right from the beginning on. Education and training, when you have a new, let's say, maintenance system and you want to train your workforce on it, we can do this with our demonstrator, because when you break something at our demonstrator, it's not that bad as if you would be in an SME and the entire line stops. Then, for international delegations, we have presentations and workshops on the topic Industry 4.0, which is still a very, very hot topic, especially in Asia. And for educational institutions, we have lectures and workshops where we go to universities and schools and basically excite the students for digitization, because, you know, you got to teach them young. So at the end of our presentation, we would like to give a big shout out to what this conference today represents. It's a very innovative ecosystem. We are here together, and from our own experience, we can say, from becoming innovators and founders, from being researchers, we got encouraged and supported by the university. And also when we needed help with our PLC, Siemens was there to support. And therefore, we can say from our own experience, this network here works. Thank you very much, and let's stay in touch.
So thank you so much. Unfortunately, due to the time, we will not have a question session. We will move straight to the brain date. So let's take a startup brain date with Benjamin Bauer, who is the CEO of Zollhof, which, as mentioned, is the tech incubator in Nuremberg. And it plays an important role for all of the startups in the research and innovation ecosystem Erlangen-Nuremberg. So I welcome you on stage.
Thank you so much for the introduction. I'm Benjamin, I'm the CEO of Zollhof. We're a tech incubator. Siemens and FAU are 2 of the founding members. We've supported over the last 4 years more than 70 startups with a combined valuation of more than 400 million euros. So we support early stage tech startups. And I'm happy to kind of have a really quick dragon stem simulation. So I will get into the role of the evil investor and ask some questions. But also, please, as the audience, you're of course included and can ask some questions. I will ask the first question, and so you have time to think about a really, really tough question now. So please, the 2 startups, come on stage, join me here. Maybe the first question, if I would be an investor and you would have to show me your early traction, give us some numbers, like some facts, some key figures. What would you tell me? How would you convince me when it comes to your early traction in your product? Who wants to start? Sasha.
Yeah. Crushing numbers, that's where the hard facts count. And again, I can just continue with what I said towards the end of our presentation. What helped a lot for us was to be in this very nice surrounding of the university, because, you know, there's the FAU Academy, there's the LZE Academy, so it was quite easy to get into programs where we don't have to step on the market on our own, but be part of programs and be involved in summer schools, be involved in all kinds of offers which are given out by these institutions. So it was kind of easy to jump on a train and accelerate the numbers in that way.
Okay, all right. I'm thinking how much money I would give now for that answer, but it was a good start. Thank you. For you, Eike.
Yeah, also for us, system integration could be reduced to 20 to 30% of the effort, like with our best practice approach we did with high tech. We reduced especially the early phase, because the early phase in engineering takes a lot of time. So you discuss a lot of with the people, you have a lot of like which solution is the best, and like customer has the problem, we have 1 million euro, how to spend it. And in most cases, the business case is relevant. And if you give clear information to business case, clear first approach, I think we could reduce 50% of the effort of engineering and discussion in early phases of engineering. And like we have a small SME engineering project is about 200,000 euro, 50% in engineering, so 25,000 euros per project, and there we can get 8% for our service.
Cool, thank you. So I get that you're in an early phase, right? Like you started off from university, you're still in the spin-off phase. Do you have paying customers already, or is it maybe in a bit too early phase at the moment? Can you tell us about that?
We have some customers who do workshops with us. So what we see is like a lot of system integrators have a problem with a B2B marketing strategy. So we support like how they can get more visibility, how they can get more in digital contact with their customer. And so we have 2 or 3 customers who are doing workshops with us and also are in discussion with others using our platform.
Cool, so like validating the product, I think it's really helpful to get to a full-fledged product on the market. Really good. Are there questions in the audience or online? Okay, here's a question.
How much effort does it take you to get the data out for doing all the simulation?
I will repeat the question for the online audience. So how much effort does it take you to get the data for your applications? Was that the question, right? Okay.
Yes. Currently, it's a little bit more effort because we're just learning, and it's also like how to prepare this best practice. So you saw the best practice in my presentation, and like we have a model how to structure the information to get it more understandable, to get it more easy. And at the moment, we're doing a lot of with handwork, but as more traction is coming, we're automating this process. So like every early startup is doing a lot of handwork for validating the business cases, and the more custom you get, the more you automate your processes. So at the moment, we take 3 to 4 days for one best practice, but I think we will get down to just a mouse click.
More questions? There's a follow-up question.
Will the customers pay then for a pay-per-use? Is this a subscription, or do you have a different business model behind it?
So the question is the business model, is it a subscription or pay-per-use, or what is the business model like? Can you tell us about that? And maybe then also the question to you as well, how does it work in your business?
So to get an easy access, we just want to like commit for the contracting. So at first we are free for basic stuff, and for advanced stuff we just get freemium stuff. And so it's freemium pay-per-use, and also like if we get customer for a company, then we just get some provision for that.
Cool, interesting. Sasha, how it is for you?
Yeah, our business model is based on 2 main areas. On the one side, we have subscriptions for the web tools, and this is where we are quite scalable. We have customers from Germany, but also from other continents, who just use these tools for their digitalization purposes and profit from the continuous actualization of the content of these web tools. And then, of course, with the workshops, if it's for the development of new systems, or, for example, when we go into schools, this is basically like an investment in the future in our kids and children. And what is quite cool there is that public funding is available also for this. So the schools, in the end, don't have to pay, but they get funding from the state for these kind of workshops.
Okay, thank you. There is a question also, I think, from online, and it's about female founders and female entrepreneurship. How would you see this? If you look at the slides, and you look at the startup scene, I think 16 to 17% in Germany are female founders. I think it's a topic we should talk about. How is this in your team? What does diversity play a role in your teams?
Yeah, a very diverse stage at the moment. But No, we have one female founder with us. She's not here today, but I think it's quite important to have diversity in teams, because as we know it from all kinds of studies, and as just reality shows us, everyone has different backgrounds, can bring different things to the table, and therefore we very much enjoy to be not just a male starter.
We have a lot of online viewers, but also the participants here are very, very important people. If you have a wish to the audience, what would you wish? Like, what is your, maybe, I don't know, a question or a wish for cooperation maybe, or a wish for getting new customers? Feel free to, spread that in the audience. Maybe, Eike, for you, you can start. What is your wish to the audience, maybe?
So our wish for the audience is like to support startups, especially in the early phase. So if you see there's a lot of research funding, then there gets a dip for the early phase of startups, and then if you get some traction, then you get a lot of money again. But between, there is some hole, especially in Germany. So if the ecosystem could support even startups in these early phases, because it's very important. I think at the universities are a lot of good ideas, but there is a lag between. And especially to Robotop, we would like to get more in contact with Siemens and discuss our business ideas, and to get insights like how we could support a company, like could we provide a white label solution for internal information flow, like if Siemens knows what Siemens knows, then there would be a lot of so we can discuss maybe later. So if Siemens knows what Siemens knows, so if you just take this approach to large companies like Siemens, make their best practice internal to all their facilities where they produce available, and then they can see how do others do it, just for internal knowledge share, I think a lot of would be won, and a lot of efficiency could be there.
So a call out for investors and to Siemens directly. Sasha, what is your wish to the audience?
I can only say I really like to invite to take not just a technical perspective on this topic, but also a very organizational one and stakeholder driven. And where I see potential for cooperation is we have a very good idea about what certain stakeholder groups think about this entire topic. Siemens has so many customers and knows where the problems are in the market, where products can be sold, but the services around it are something that could be optimized, and I think this could be a field where the ideas find a way to the market.
It's also a call for new customers and cooperations. Thank you, you two. It was nice to talk to you, get some insights. I hope you had fun and enjoyed the discussion here. Thank you so much, and enjoy the conference.
So just to wrap it up, today has been very insightful with the knowledge that we have all gained on the factory of the future. And this just goes to show us what a thriving society and ecosystem we have in here. I would also like to now draw your attention to the upcoming events that we have. And you're all welcome to join our Digital Student Tech Talk on the 8th of November. And for the students, you also have a chance to win a VR headset. So be sure to tune in. We also have another event on the 4th of November from another ecosystem of Aachen, and you're also welcome to join that as well. Moving on, be sure to provide us your feedback and outlook on today's conference using the QR code that is displayed here and also on the impact wall on the side. And feel free to do that right away. And with this, I would like to thank all of the audience that has joined us both live and online, all of the speakers for sharing their insights with us today, and the research and the industry experts, and most importantly, the organizers that made this event successful. For all of you present here, you're now welcome to have lunch and also network together. That's it from my side for now. Stay safe, healthy, and until next time. Thank you.